Good morning, everybody. Welcome at the NCP 515 exam preparation webinar. Today we'll be giving you a recap of the NCP training material. And we have the following agenda for you. My name is Martijn Bosgaard. I'm joined together with Tom and Ophir, who will be your instructors and presenters today. And as panelists, who will be answering all the tough questions are Oliver and Sebastian. So if you have any questions during the webinar, please use the Q&A functionality so we can keep track of who's asked questions and which one we have answered. And please use the chat for interactivity during, for instance, the Q&A session. Before I'll hand it over, some stuff I want to address. So first of all, welcome back to school. This will be really an exam cram. So it will be pretty much drinking from the fire hose. It's a morning of a lot of information. We're condensing the whole NCP track in one small morning. But important again, as we stated in the email, is that this is not a replacement for the full course. So if this is the first time that you see the NCP material, I suggest you do some more studying afterwards to be able to do the exam, as we'll only touch the highlights. And we don't have time to cover all the topics that are being asked in the exam. So there will be stuff in the exam that is not going to be covered today. That's important to know. So NCP is our certification for people that actually use the software. We have some pre-sale certifications. That is how to sell, but this is how to use the software. It's focused on end user system administrators, but also our engineers at partners that implement or do consulting services. So you should have done already the ECA 515 or 510 course. I'll have a remark about that because it's not that different actually. Which you could do on the Nutanix University. The certificate will be yours if you pass the proctored exam. That will be an exam consisting of 75 questions, and you have 2 hours to do this in, and it will be done online. If you want to pursue further certifications like NCS or NCSE, this is a prerequisite for this. And there's a blueprint on the partner portal that pretty much looks like this. Might look a little bit different because the difference between 510 and 515 is just a reorg. There's actually not much difference between the two. We still count this as an NCP 5. So if you have either of these, so if you do the exam today, the 510, you will get just as many credits as 515. So the only two things that are really different is that in the blueprint for 515, you'll find that monitoring and robo has been split out into a separate category. But pretty much all the questions are the same, and the new exam will be more a version update with some typo correction and some layout changes. Then it will be really a different exam. So everything you learned today will be valid for 510 and also for 515. So this is where we are, roughly. We'll break it up in sections. Between each section, we have a short break. So there's 2 5-minute breaks, but also a 15-minute break. So it's going to be an intense morning. The meeting will also be recorded. You will be getting the link afterwards. So don't worry if you miss something or you want to review something again. Make sure the question functionality, the guys here can answer all your questions. So finally, when you've done this, you can do the actual exam. Short instructions to do the exam. You need to do this through the partner portal. If you click the Learn menu there, or you go to Nutanix University, there's also an option to get through the exam system for those of you that haven't done so before. You can actually grab a free voucher currently. If you haven't attempted the exam, the first attempt is free. This works until July 31st. There's also a free attempt if you have used this and you want to do it again, because unfortunately you maybe didn't pass. You can use that discount code that's on screen for $149 off. That leaves $50 left. So should be good to try and get your exam there. There's also something called Xstripe, and because you participated here, we're going to reward you for this. During the break screens, we'll have 4 keywords put on the screen. If you collect those and go to the Partner X Tribe, you see the link here. If you haven't used it before, you need to sign up first, but you use your partner portal account to do this. Once you logged in, you need to find the task Get Prepared Now, or the challenge as it's called, and you get some additional 100 points to get you started on X Tribe. But also, if you complete NCP, you'll get another 2,000 points. And the whole point of X Tribe is to give you some rewards back for your time spent, so you can get Amazon vouchers and some swag and some other cool stuff. But with the challenge in place, if you complete the challenge with the keywords, we'll give you, or we'll raffle you, the first 100 that complete this challenge. We'll raffle off a 3-month full access pass for Skillshare, so you can do some extra learning on other topics besides Nutanix. You have until July 31st to complete the challenge. So without further ado, I'm going to let the smart people talk. So I'll hand it over to our presenters. If I'm not mistaken, this is Tom. I'm going to start this off, and I'll stop sharing and hand it over to you. And I wish you a knowledgeful morning. Off to you, Tom.
All right, thank you, Martin. Just give me a couple of seconds. So you should have visual right now.
Yes, we do.
All right, so good morning from my end as well. So let's get started with, I would say, the first section of this morning, and hopefully no surprises here. This is really the beginning of, I would say, Nutanix and its concepts. So where did we start from, and where did the Nutanix story started? And if we just go back into, I would say, history, it is pretty clear that the fastest way to serve data to an application, or to put storage as close to an application as possible, has always been the best way. So if you go back, I would say, to 1990s, then basically the only thing we had was storage locally in servers. The big problem, obviously, there was that utilization was pretty low of these servers. So that's hence why I would say years 2000, we moved into something we probably all know today as virtualization, where I would say multiple servers run multiple VMs with their specific applications, and they're connected in one way or another to a storage fabric, where I would say this storage is managed by LUNs. The big problem, if you can call it like that, is that there is no real VM awareness in this. The storage is just presenting shared resources to our physical machines in order that I would say these virtual machines can so-called, call it vMotion or move or have high availability as a feature perspective between them. But there's lots of, I would say, downsides which exist in this world, like having multiple vendors from a servers and SAN world. There's probably weeks that people need to go through, or months, to design, procure these things. How do you scale and deploy and meet capacity enhancements in this, I would say, so-called 3-tier world? Not to think about if you need to do troubleshooting, where do you start looking? Virtualization console, storage console, who's the one to blame, etc., etc. So there's whole pieces which makes this, I would say, old 3-tier world not as simple as we think that we're used to be using this for I would say lots of years. And then I would say a couple of years ago, 2010 and later on, Nutanix came to market with the introduction of, I would say, a real fully integrated scale-out compute and storage principle. Let's call it the so-called hyper-converged world, where everything that we do is from a storage management perspective, really VM-centric. We're really trying to put the VM at the center, where the VM is important, or the storage is I would say, really happening from a VM disk level. And the combination of, call it, our operating system from an AOS point of view and this hyperconverged model where we combine, call it, CPU, storage, memory in each node and scale up depending on, I would say, the kind of performance that you would want to get out of this system. Okay, so the more performance you want, you can basically just scale node per node, adding, I would say, compute and storage into the mix. Obviously, over the years, lots have happened, or lots has happened in regards to, call it, compute-only nodes, storage-only nodes, but the basic concept obviously still is there. Now, I would say some basic vocabulary that you probably already have run into, or I hope at least, are a couple of these terminologies. So things like nodes, blocks, a cluster, etc. So hopefully this is nothing new for anyone here, but what are we discussing? So a node is nothing more than the real, call it, physical assets. So call it the typical x86 server that you used to use in the past as well, from multiple vendors, and we might see them later on, I would say, being referenced. But think about, I would say, the Lenovo's, the Fujitsu's, our own, I would say, Supermicro based models, Dell, HP. So everything that you'll see from a server model that is listed in the HEL basically can be used there, and that is referenced as a node. Okay, what is a block? Then obviously think about the block as the physical chassis where 1 to 4 nodes are mounted in, and obviously depending on, but they are sharing power within one block. And then obviously the cluster, okay, is the combination where multiple of these blocks or nodes are aggregated together and form a unified disk pool. Okay, and as you'll see on the drawing, if you really want to go, I would say, nuts, you could create multiple clusters out of multiple nodes residing in multiple blocks, etc., as you'll see on screen. But typically, I would say you'll see multiple blocks joined into the same cluster, depending on the size that you'll want to grow your cluster to. So moving forward to a couple of components, obviously, that we'll run into. What will we see and what will you come across is basically 2 major level components. Number 1, obviously, being Acropolis, call it everything that is happening under the hood of the Nutanix system. So things that you probably don't see, but what's, I would say, built up as being obviously the hypervisor, so AHV, built-in, I would say, virtualization platform. Next to that, I would say probably the major part of Acropolis is the DSF, the storage fabric, or the distributed storage fabric that we're bringing, and the app mobility fabric. So these are the 3 main, call it, key components if you look towards Acropolis. On the other hand, there's the Prism piece. So Prism, which you probably all know and have experienced yourself from a management perspective. We'll dive again deeper into Prism Element and Prism Central later on. But think about Prism as the management aspect, from where you'll do, I would say, basic management. And if you take it further to, I would say, infrastructure management, operational insights, one-click planning, these kind of things. And if you really want to move it up a notch later on, you might get introduced to Calm, so the, I would say, automation framework within Nutanix, from where you've got application lifecycle management, self-service portal, etc., etc. So these are, I would say, the main components that you'll come across. Things to highlight, maybe if you look at the DSF, this is nothing more, I would say, as the framework that aggregates all, I would say, storage resources within the cluster, and that is responsible for everything around snapshotting, disaster recovery, compressor, erasure coding, so all kind of storage features that you'll know, and that is, I would say, backed by a 10 gig network somewhere in the backend or above, obviously 10 gig or above. Probably nothing really much more that we'll need to highlight here. Most important, if you come across, if you want to use column, obviously you'll need to use Prism Central and Prism Self-Service, as column is fully baked in into Prism Central. Up until now, we've probably just discussed VM services. Now, obviously, the Nutanix platform is about much more than simple, I would say, VM services. It's a full platform. It's a full fabric, delivering much more than, I would say, simple VMs. So think about storage services. For file, think about block, think about object in the meantime. So lots and lots that you'll come across when you play with Nutanix. Next to that, obviously, platform for all kinds of virtual workloads. So, and not, I would say, the simple ones. This can go to, I would say, high application demanding things like an NSAP, a SQL Server, an Oracle, Splunk deployments. So depending on, I would say, whole lots of data, less compute to, I would say, lots of compute, less data. Everything is possible there. And then obviously these, I would say, the new worlds, as I tend to call it, everything around cloud native applications can be serviced as well there. For those that have never run into that, Nutanix has its own, I would say, container-based approach there with Carbon, which again is fully baked in into Nutanix platform. From a storage perspective, or these storage services, we'll dive, I would say, a little bit later into the presentation. We'll dive deeper into that when we take a closer look at how we're making use of Nutanix volumes, how we're making use of Nutanix files, so that you'll get a better understanding of, I would say, the architecture behind it and what we're doing there specifically. So moving on and moving a little bit to the architecture piece here. So what do we see as, I would say, major, call it hardware architecture difference between a traditional three-tier system and these new called hyperconverged worlds? Again, probably no big surprises. But if you look at the left-hand side of the screen, you'll see the old, I would say, three-tier architecture, where obviously if you start on top, you've got your virtualization layer hosting multiple VMs. That is connected in one way or another to, I would say, the storage system, where in between there is probably some kind of fabric, whether it's a traditional network fabric or a SAN fabric with fiber channel switching, etc. That is typically dependent of each customer or different per customer. But what is I would say almost all times the same is that you'll end up into a dual controller system backed by a number of, I would say, disk spindles, storage arrays, etc., etc. All right. So how does this look like into the Nutanix world, where we're, I would say, really making use of a distributed model? You'll probably already see some of the difference here, and if you've experienced yourself, we're making use of a traditional, I would say, simple Ethernet network, so no fiber channel here. We still have your, I would say, hypervisor, or per server, you've got your hypervisor, one or probably, hopefully, multiple NICs connected to the Ethernet network. You still have your user VMs, and you get a special so-called controller VM, which is, I would say, the heart of the Nutanix system. We'll dive again later into that. And we'll start to work with, I would say, local storage instead of, what we had at the left-hand side, I would say, shared storage fabric. So each node works with local storage, local disks, local CPU, local memory. All right, nothing special, or probably no surprises here. So when we talk about storage, and this is where I would say differences started to occur, we'll need to take a look at which hypervisors are being used, because probably, as you know, from a Nutanix perspective, we try to be as open as possible towards, I would say, our hypervisor. And so you can use, or you can make use of multiple hypervisors in combination with Nutanix. So for those customers who tend to use VMware as their hypervisor, we're mounting the storage that is presented to the system over NFS to these ESX hosts. If the customer chooses to make use of Hyper-V, we'll mount the storage over the SMB protocol. And in case of the Nutanix Acropolis hypervisor, we'll basically use some iSCSI in the backend to, I would say, point the disks to the storage fabric. So how does the world look from a storage point of view, or how is this looking? So again, the left-hand side, what do you see? Well, you'll see the traditional, I would say, servers connected to your SAN array, if we can call it like that, depending on, I would say, the connection mechanism, iSCSI, NFS, or SMB. And then obviously this is, I would say, transitioned into the Nutanix world, where each node, again, is working with local storage, combination typically of flash tier and, I would say, traditional HDD tier, spinning disks. And it's the combination of, I would say, our multiple nodes, each local disks, all forming together a physical pool, or what we reference into Nutanix as our storage pool. Okay, so the storage pool is the combination of all disks into the system. Okay, and from a logical perspective, you could say this is our DSF, our distributed storage fabric, and it's within the storage pool that we start to create these so-called containers. And it's these containers that we are presenting to the hypervisor or to the outside world. Okay, so from an ESX perspective or from a Hyper-V perspective, you'll mount, or you will be able to see a container. Okay, and you will have, or you can have, multiple containers within one storage pool. Typically, you'll only have one storage pool per Nutanix cluster. Probably nothing more that I need to highlight here. We'll dive again deeper into the DSF later on, and into options that we'll have from a container perspective. So moving to, I would say, the heart of Nutanix, our controller VM. Okay, so our controller VM, what is special here? Well, each obviously node, okay, is running a CVM, okay? And it's this CVM which has access directly to its local SSDs and HDDs, okay? It is also the CVM which is connecting or communicating over the network with all the other CVMs across, I would say, the network or within the same cluster, combining all resources and presenting the so-called shared storage pool to all the nodes, okay? It's this CVM which is running our Acropolis operating system, okay? So that is really the heart of Nutanix. The CVM runs AOS, and one of, I would say, the, call it, interesting features is that we can basically, and we'll dive again later into that, upgrade AOS independent of the hypervisor, and basically without any impact to, I would say, the rest of the cluster. Okay, it is the CVM which is exposing the user interface known as Prism. Okay, it is the CVM which is responsible for all, call it, storage related operations, if we can call it like that. So everything you think about within a traditional storage array, think about snapshotting, cloning, high availability, disaster recovery, deduplication, compression, erasure coding, and we can go on and on. These are all tasks that the CVM is responsible for. Okay, so as we'll see on the drawing, is the CVMs which are talking to each other, communicating over an external, probably top of rack switch. A default storage pool or storage pool is formed out of all local disks into each node, okay? And it's our CVM which is presenting, I would say, the so-called management framework in the form of Prism elements. But as you'll see, each CVM is exposing, call it, its own Prism element interface, okay? And storage is being mounted or to the hypervisor, depending again on which you're using, H.V, ESX, Hyper-V, on a protocol, NFS, iSCSI, SMB, depending on the hypervisor. All right, I hope this is clear from an architecture point of view. So moving on and diving again a little bit deeper into CVM. So what do we come across? Read-write paths. So how is this happening? So user VM doing I/O to the hypervisor. Hypervisor is giving that I/O to our controller VM, which then again in his, I would say, way is talking directly to the storage controller within the physical system. And the storage controller is obviously hooked up to multiple SSDs and HDDs. So if you dive deeper into the storage and read-write paths, what do we come across? Then you come across this kind of drawing, okay? What is the most important here? So obviously there's a number of things you might have already heard about. If a write comes in, typically, or most cases, random writes come in, they're going to uplog. And uplog is nothing more than, call it the buffer in which the Nutanix system aggregates all writes and basically coalescing them and draining them to the extent store. Okay, so what do you see on the drawing? Uplog is located on the SSD tier. The extent store is basically our, call it capacity tier, or our, call it the capacity tier. And this can, I would say, is part or slightly parts of the SSD tier, depending on the remaining amount of capacity that is available on the SSD. And its most part, I would say, of the extent store is located on the HDD tier, typically the traditional spindle tier. What else do you see? There's also something we call the unified cache, which is located for parts in memory and a part on SSD, and that is typically from where read I/O is being surfaced. Okay, as you'll see again on the drawing, as you'll see on the drawing, random writes going to uplog, sequential writes can skip uplog and go directly to extent store. Okay, so that's important there to know as well. Something we'll dive again deeper into the presentation is something we call replication factor. So call it the amounts or the amount of copies that you want or need for your data. In the Nutanix system, this can be 2 or 3. And so how that is handled, we'll see that later on. Basically now. So what is this redundancy factor? So either 2 or 3. It is nothing more than how many copies of data do you want for a specific write? And obviously it also has to do with the number of nodes inside your cluster. Might see that later on, but obviously RF2 means I'll need 2 copies of data, as you'll see in this diagram. So what do we see here? Some VMs on node 1 are writing. What does that mean? That data ends up local to that node. Okay, so we are writing locally to that node where the VM is running, and a copy of the data is ending up somewhere else in the cluster. So there is no fixed location where this data is going. The cluster decides in a fully distributed manner on where this, call it secondary copy of data, is being written or being replicated to the other nodes, depending on the RF factor. So moving on, if we again dive a little bit deeper into the CVM, which are the components that you'll come across? There are many more, but basically the main 5, as I call them, are these. Okay, so let's quickly walk through them. Stargate might ring a bell for a couple of I would say guys who watch some television maybe, but Stargate really is call it the I/O manager. It's the place where our hypervisor is typically putting its request from a storage perspective. So it's the portal for I/O. So this is where your hypervisor is connecting with NFS, iSCSI, SMB, and sending its request for I/O to. Okay. Next up, that we could discuss is Zookeeper. Okay, Zookeeper is there to keep the configuration of the cluster. Okay, so it's your configuration manager. Cassandra is your call it distributed metadata store. So call it your database, which holds all information about metadata of the cluster. You've got Curator, and Curator is your call it cluster management and cleanup interface. A simple way to know what Curator is doing in the backend is, let's say you have written multiple copies of data, or an I/O has happened, and for some reason you deleted the VM, let's call it like that. It is Curator's job to clean up whatever actions you have taken and to do the necessary from an I/O perspective. And last but not least, you've got Prism. Prism is everything that has to do with what you touch from a UI perspective. So everything that you initiate from the UI, from an API, etc., is basically an interaction that you'll have with Prism. So you are taking your browser, your orchestration workflow, etc., and you'll talk to the Prism interface, and then again, this action gets executed. So these are, call it, the major 5 components that you'll come across and that you probably need to remember from an exam perspective. All right, last piece here around, I would say, the initial cluster components and states, data locality. I would say major important piece within Nutanix. So what is this? Basically nothing more than, as I've said in the beginning, if a user VM is doing some I/O, we'll tend to keep that data local on that node. So writing locally, sending a copy of that VM or of that data towards a other nodes in the cluster. Okay. Next to that, obviously, there is something you could call, or that we could call, the ADS. Okay, or Acropolis Dynamic Scheduler. And so what is this? Call it maybe a little bit the DRS, I would say, that VMware has, or that vSphere has. It's a hotspot detection system that will automatically initiate a live migration if a specific hotspot occurs onto a node. So if we see that a specific VM is doing too much I/O or consuming a high amount of memory or CPU, we can move that VM to another host. Now, obviously, in the event of a live migration, that I would say that VM that is moved will lose its, call it, data locality, if we can call it like that. But again, if, for example, that VM that we have running on node 1 would move to node 3, it will just write local again. So it will just continue to write local to the node, and we will read the blocks over the network that are not local to that node and make them local again. All right, hope that is clear. If there's any questions, post them in the chat and we'll try to get them answered as soon as possible. But that is more or less how I would say the data locality and live migration works in the background. So I hope most of these introductions were clear. So let's move to a couple of, I would say, these practice questions that we've built into, so you get a little bit of a feeling of how I would say the exam kind of questions might be. So how does this work? Well, typically there will be a question on the screen that you'll see now from a PowerPoint perspective. You have, let's say, 30 seconds to a minute to answer each question. Try to keep the answers into your minds, and then we'll pop up the answers and try to maybe even give a word of explanation, would that be necessary. All right, so.
If you want, you can put it in the chat. So let's see how fast people can react to it. So
okay.
Yeah, because we need to speed it up a little bit. So
yeah, we'll need to speed up. Okay, perfect. So very first question. Match up the correct hypervisor with the CVM storage protocol. Should be an easy one. Are we good?
Yeah, it's not one answer, people. It's more answers than just one. You need to match all three. But the ones that I've seen so far are all correct, so yeah.
So let's move on.
Yeah.
So the right answers were
Don't look at the colors, look at the letters. So 3, C is NFS, B, so yeah.
all right. So next question. How many CVMs per cluster? Should be an easy one.
I see a couple of C's and I see a lot of B's. Well,
okay, so the
let's see what
right
the
answer
is, because it's
equal to the number of nodes. So every node in a cluster, so each physical asset, each physical x86 server is running a CVM. Okay. Third question.
Oh, guys, please don't answer the questions in the Q&A pane, but just in the chat window, please, if you want to.
So match correct services with their function. So this will take some time, but think about what we just discussed. All right. So the right answers here, we probably more or less just discussed this, but Zookeeper is everything around configuration data. Cerebro service, which we did not discuss, is all about snapshotting. Stargate is the one doing IO, so read-write requests. Medusa or Cassandra is the one that has to do with metadata. Curator is periodic metadata scans, and so doing the cleanup in the background. And Prism is your web console. So question number 4, what's the purpose of Nutanix oplog? Is it a file repository, sequential IO buffer, and memory space, or a random write IO buffer?
Lots of D's.
Lots of these? Well, then I'm probably on the right track, because D is the right answer. Last question in this section. So what HV feature is providing hotspot detection and is invoking live migration?
I see a lot of B's.
Lots of B's.
And more B's, even more B's. So I guess it should be.
Yeah, that should be good. That should be good. All right. So let's move on to section number 1. Try to speed up a little bit. But so section number 1 is all around management of a Nutanix cluster. So obviously, when we talk about management, there's, I would say, 4 main ways, if you can talk, or 4 ways to do all this. So obviously, probably most of the work that you'll do is all through Prism, the HTML5 GUI. But if you want, you can do management over PowerShell, over the REST API, or just by using the CLI methods. All right. So before I jump into the demo, let's quickly go over a couple of other slides and then take the demo at the end. But so if we talk about, I would say, the command line interfaces, you can connect into the CLI by connecting, I would say, to a Nutanix cluster from either your local machine to an, I would say, a PuTTY session or an SSH session. And what you can do from there is basically two kinds of, or the most known two kinds of command line interfaces are NCLI and ACLI, okay? Call it maybe the more storage and cluster related one, which is NCLI. So NCLI is the CLI which has to do with, call it the storage piece of the Nutanix system, okay? ACLI all has to do with, call it the Acropolis part of the Nutanix system. So let's say you want to create VMs, delete VMs, maybe do some couple of things around networking, manage the hosts, etc. So these are all commands that you would go to and they would do over the ACLI framework. Okay, so hope that is more or less clear, the difference between these two. Two common, really, I would say, commands which come in really, really handy. Okay, so where do you find them? Sorry, where do you find them? In the Prism menu, I'll show that later on. You can do download NCLI, so one way to interact, or you just use a traditional, I would say, SSH terminal with, I would say, IP addresses of the CVMs or cluster IP. And there's a full command reference available with all things that you can make use of online. So two major commands that you can make use of within the Nutanix system is all SSH and host SSH, okay? All SSH is basically a command. Once you give a command over all SSH, this command is executed on all CVMs within a cluster, okay? So for example, what they're doing here is they give a command all SSH, okay? But then they SSH into Nutanix at 192.168.5.1 and they ask for a specific output. So what they're doing is, obviously, if you know a little bit what is happening, they're SSHing into the HV host or into the local hosts, the hypervisor, and executing a specific command over HV to ask the networking bond information. I would say a different way or other way of doing something is by making use of host SSH. It's a command, again, that you run from a CVM and is executing a specific command on all hosts in the cluster. So a different way to do, I would say, the above command would be something like host SSH OVS appctl /show. All right, but so these really come in handy if you want to get information from all hosts, all nodes into the cluster, typically used a lot by support to get information if they need something around time, date, configuration state of each CVMs, etc., etc. Other way, as discussed, I would say to manage your cluster is by making use of PowerShell. Where do you find the necessary commandlets, etc.? Is again over in, I would say, the user menu, or depending on the name that you're logged on with, click on your name within Prism, download the necessary commandlets for PowerShell. And then obviously you'll need to meet the minimum requirements like having PowerShell v2, the .NET Framework 4, and then obviously from there on, you'll install the necessary commandlets and you can start managing your cluster by, I would say, the given commandlets. Last, I would say, way of doing management is by making use of our REST API. Okay, because as you know, probably the whole Nutanix system is fully API aware. It's built on a set of APIs. Everything, we do in the background has an API, and you can, I would say, manage a whole lot of these things, even, I would say, available, again, same place, admin UI, REST API Explorer, and you get a full view on what is available from VM perspective, host perspective, all the operations that people can make use of, get, post systems, all available there. So, right, let's now jump into the Prism part. So if all goes well, just give me a couple of seconds. I'll start to share my desktop. So if all goes well, you should now see my Prism logon screen. Martijn, can you confirm?
We can see it.
All right. So let me quickly log in here. So I hope you all have seen this at least once. I would say I would highly recommend for the exam that you'll spend a lot of time within Prism, that you'll know how flows are going, how the UI interacts, because I know from heart there's a couple of questions about just the screens that you'll see within the UI. But so what is important, I would say, as an exam cram, I would say to keep in mind, notice the ports that we're connecting into. So 9443, okay, so that's I think one that you should remember. What else do we see? Obviously the home dashboard gets you a lot of, I would say, information. First static one, dynamic, I would say, controller IOPS, IO bandwidth, latency, CPU and memory for the cluster, a health dashboard, looking at the full cluster health with disk VMs, hosts, remote site connectivity, etc. We've got a resiliency status, which if all goes well, it says okay. And so if you click on that okay, you'll get into a detail of our resiliency status. So what can you lose, or how many failures are tolerable? So that is important to mention. What else do we see? So I can click on my admin menu here, or on my name that I'm logged on with. From here, there's a couple of actions I can take, like changing passwords, but as well, as we've seen, download or access the REST API Explorer, download the NCLI, download the PowerShell commandlets. What else do we have? We've got the question mark. Okay, the question mark allows us to access a health tutorial, access the .next community, help with this page, I think that is obviously, access the online documentation, and access support portal. So that's the only actions we can take over this help menu. What else do we see? Let's maybe quickly browse, I would say, over the menu here, but typically most things you probably already have seen. So I can switch to VMs. I'll get an overview of all VMs we are running into this cluster. I can switch to a table view. Clicking on a VM gets me the details of the system that I am running into. So performance, disks, NICs, snapshots, IO metrics, etc. Switching over to, for example, network, I'm able to see all my virtual networks, how they are connected to each host, maybe even to which switch or switch ports I'm connecting into. If I would go to storage, I can go, for example, to my table and I can see my storage pool, as you'll see. So my aggregation of all my disks into a storage pool. And it's in this storage pool that I create multiple containers. Which containers do you typically see? Well, by default, you probably always see a self-service container. You'll probably always have a Nutanix management share. And I would say, I believe, default after foundation, you'll get something like a default container with, I believe, your cluster UUID that are created. Okay, obviously you can create your own containers, do whatever you want there later on, but there's a couple of ones which are created by default. So default container, management share, and self-service container there. There's a hardware section, obviously, to list your hardware and to see all, call it hosts in a cluster, disks into the cluster. And a nice thing I always find, if I sort, for example, by tier, obviously this cluster is really lightly loaded, but you'll see that we'll first fill the SSD tier before we start to drain towards the HDD tier. Okay, so we first try to fill all SSDs equally before we need to start draining towards the HDD tier. I would say most important, or a couple of other important things are within the settings piece. Okay, so what is important when we look towards settings? There's a thing that we call Pulse, which you probably all know. So what is Pulse? Call it an automatic support system. So aggregating and providing diagnostic system data towards Nutanix support. Okay, so that basically Nutanix support is aware of what is happening in the background, but more importantly, no, let's say, user information is given to Nutanix support. So Nutanix support can see, call it alerting, statistical information, configuration information, but there is no VM naming, etc., that is being sent to Nutanix support. All user data is obfuscated, okay? It is just purely from a support perspective that the necessary statistics and diagnostic data is being collected, all right? What else do you see? Obviously, if you go to upgrade software, this is where I would say necessary upgrades are happening. So AOS, file, hypervisor, NCC, and foundation. So those are the major components that you'll see from a software upgrade perspective here. I can enable automatic downloads, or I can upload manually. If I need to upload manually, I'll need to supply a metadata file and my software binary file. Okay. Scrolling down a little bit, what else is important? If I go to my SSL certificate, you'll see obviously there is in this case, a self-generated certificate. If for some security reason you want to replace this certificate, obviously you can regenerate a self-service one. If you want to make use of your proper own company certificates, what do you need? So you probably go to import key and certificates. You'll choose your key type, so RSA 248 or an ECDSA, which I would say depending which bit length you want there. And then obviously the necessary files, you need to supply the private key, the public certificates, and the chain. So these are the 3 files that you'll need, and the key type.
Thanks, Tom. This looks good. We have to move on to the demo, or the demo questions now. Yep. Otherwise we'll run way over.
So let me quickly again go to questions. These are like this. All right. So number 1, Prism listens on port 80 and what port?
Lots of C's, so are they correct?
Yeah, I think they are. All right.
Yeah, this is something you just should know. There's no understanding, it's no concept, it's just this number.
Yeah. Number 2, again, pretty easy, I hope, but which is true for all SSH and host SSH. And there's a multi-answer available, so you need to supply more than one.
Looks like we have a majority for A and D.
A and D?
Yeah.
All right, these people have it right. All right, number 3, if you want to get the version of your cluster, what CLI would you make use of?
We have a C, we have a D, more Ds, another C. Oh, we're split over this one, Tom.
Ooh, a difficult one. All right, so typically if we want,
we don't have the ECLI, so we can already that one from
that makes it easy. Typically, if you want the cluster version, what you're after is the AOS version of your cluster. And AOS typically hence means the storage related one. Yeah. So the CLI that we run into is the NCLI in this case. All right, going forward, question number 4. what information are we sharing through Pulse? Again, multi-answer. I need more than one.
I think it's really important to know here, especially if you're in a sales conversation, to know what we're not sharing. Lots of C&D, system alerts and system level statistics.
Yep, all right, that's what was needed. Okay,
now, we don't
perfect.
send any data back to our HQ that could either identify VMs or something to do with names or whatever. So it's purely on system alerts and anonymous data on some statistics.
Yep. All right. So last section before, I would say a very small break. This one will be a really quick one. So securing your Nutanix cluster. So what do you need or what is happening from a security perspective? Again, I would say major thing here is that we're making use of a thing that we call a STIG, so a security technical implementation guide. So remember STIG. And that STIG is implemented by making use of something we call a security configuration management and automation framework. So the SCMA. And so we're monitoring basically over, slide says 800 security entities. So 800 rules checks basically are continuously monitored, covering, I would say, a whole kind of aspects. So security, storage, virtualization, management, and we're constantly looking for, changes that are, call it unauthorized. So thinking about setting root access open to the CVMs, etc. To make a very easy example. That's a change that is basically not allowed by this TIG and will get auto-remediated by this SCMA. Okay, and so they're all, I would say, constantly monitored, and all output is being logged to syslog. The whole idea is that it's fully self-healing in the background. Okay. Another thing around security is that obviously we can make use from or for encryption of the data residing on the Nutanix system. This can happen in two ways, either by making use of making use of self-encrypting drives, okay, or by making use of, I would say, software encryption into the Nutanix cluster. In all cases, you'll need a key management server that serves as, I would say, the ability to call it unlock or to identify a host. Okay, this key management server, again, can be an external one or can be, in the case of software encryption, can be the Nutanix CVMs themselves. Okay, so that's important to remember there. Anything else I need to mention here? I think these are the most important things. Self-encrypting drives, software enabled, external. So it says external key management. That can be a CVM. I think we have most of the important stuff here. So software-based encryption uses AOS. There's no way that you can access the data directly if you get a drive out of the system. This is, and Martin, correct me if I'm wrong, depending on which hypervisor you are running. So with AHV, it is the full cluster. If you are running ESX, you can do it container aware. Data is encrypted, at all times.
Question in the exam, so don't worry about it.
Okay. So key management server, encryption, minimum 3 nodes, etc. there. So that is all clear, I hope. Moving on, clients authentication authorization. So obviously, when you log into Prism, you'll need to supply a username and password. Can be a certificate as well. You can make use of local accounts or an Active Directory. SSL-based certificates authentication for console access is possible as well. Obviously, you'll need to replace the default self-signed certificate there. And the 3 roles which exist within Prism Elements, is a user admin, a cluster admin, and call it the default viewer account. So, okay, so depending on which role you give someone, they have specific accesses within Prism Elements. So remember, a user admin, a cluster admin, and a viewer. Last but not least, I can, if that would be needed, go for a cluster lockdown. So what we do there is basically from within the settings piece, you can basically, yeah, make it so that you can only access over a yeah, SSH key pair to get, I would say, a truly secure system, so that you're unable to access the system by yeah, password-based authentication. Hopefully that makes it clear, and we can go to the last round of questions here. So again, ready? Go for question number 1. What is the purpose of the cluster lockdown script? This should be easy. We just discussed this. Do we see the right answers coming in, Martijn?
Yeah. We have a mix, but majority says B.
Well, then the majority is right, because the cluster lockdown script is indeed there to disable password-based SSH connections. Okay, so we're not fully locking down a cluster, we're just disabling the password-based approach for SSH connections. Number 2, what is, I would say, the other role of the purpose of a KMS or a key management server beside managing, yeah, the keys of encryption?
Lots of A coming in. We have a single C. We also have a B, but the majority has A, oh, a couple of Bs. So we're divided. Well.
Ooh, okay, so I did a bad job then. So what is the KMS doing? The KMS is, beside managing keys, is doing authentication of the Nutanix node. So if a Nutanix node boots, to make access to the data, it first needs to authenticate to the KMS to make sure that he is able to access this data. And then he can start the necessary VMs or make the necessary changes to the encrypted data. Okay, so the KMS is doing nothing around in-flight data or user login authentication, etc. It's pure managing encryption keys and authenticating nodes when they boot. Which 3 roles can be assigned to a Prism element user? So we're looking at multiple answers here. There's basically one, I believe, one wrong one in there. Are we good?
Lots of A, C, and D.
A, C, and D. All right, that's the ones that we were after. Okay, so that was, I would say, part number 1. And I've got a very small break now, I believe.
Yeah, we're a little over 10 minutes, so we'll be back at 10:15. And be sure to grab the first keyword, which is now on the screen, because that's the one that you need for the X-Tribe challenge. If you missed the opening of how that works, just watch the recording back when we'll share it later, but make sure to grab the word here. So we'll be back at 10:15.
So over to you, Ophir.
Hey, I just share my screen and put the break note. I will also go to take like a water, and we will start in a 5.
Okay. Ophir, you're back again too. I see the mouse move. And now you need to unmute.
Yep, I'm here.
Okay, the floor is yours.
Okay. So thank you. Thank you, everyone. Thank you also, Tom, presenting before of me. Feel free, we have continue, and just remember, feel free to ask the questions in the Q&A area, and the panelists will help us to get answers as soon as possible. So I will speak about, in my section, about networking. And networking is, I think, a very important part to understanding in the area of hyperconverge, and to understanding how the connection is going over. And I will move these details in the sector of everything. So I will start with how the networking is structured. And if you remember, as Tom mentioned before, we have on any host, we have a controller VM, and the controller VM is getting the networking and is doing and giving the storage and his disk to the servers, and continue and together speaking each other with the networking. So if I'm looking about the controller VM, the controller VM have three types of networking, three networking card. Two is configured by the default of the installation. We have ETH0 in the controller VM. It's the public IP and the floating cluster IP addresses. And every controller VM have this networking. In the ETH1, we have 192.168.5.0 segment that will return in all of the controllers VM on the same networking, and this is the connection between the controller VM and the host himself. So each host and each CVM have the same IP addresses. Once CVM have two IP addresses, one is .2 and the second one is .254. And this is the way that our host is connected and speaking, and the controller VM is also speaking together with this host. Be aware that this virtual switch, and I will present it in the next slide, but this virtual switch is not belong to any physical network adapter. Okay, the physical network adapter will be connected only to ETH0. We have connected and created also ETH2, and I guess in the new version you will see even more ETH adapters. We want to do, like, if the customer is want to do a network segmentation, for example, in our demo here, if the customer want to create and then configure something that's called backplane, and it's to close the storage traffic between the CVMs and the host to an untagged networking that will be related and doing the entire storage traffic and data traffic between the controller VM in a separated VLAN, and it can change, the traffic. We are calling it something that's called multi-homing on the past, if you remember. So now we are calling it networking backplane. For future versions, we released already in the 5.15 version something that's called backplane for volumes, and in 5.17 and next we are going to release a networking segmentation for replication and other communication that a customer can segment their networking and everything. In the physical area, as I said, we have ETH0 that connected to the physical NIC, and with that we are to make our life easier, and I think one of the main things that Nutanix is also looking at is how to do things like in a one-click operation or in an easy way operation that we don't need too much networking or too much software to manage our environment. And we have done in a system for corporate hypervisor, we have done something that's called network mapping, that it's giving us the full networking mapping of what we are seeing. For example, we can look about the VMs and see in which hosts they are based on the vSwitch that we are creating, and then we can see on which physical port is based. I will take examples of, we had like issues with a VM or with the networking, and it was always very hard to troubleshooting and understanding where is my issue and where is my connection and how my host is based on networking. So if I'm entering to the network visualization, the demo or the GUI will be look like that we are seeing the CVM. Okay, from the CVM we are seeing bridge 0 that connected to a bond 0, and we can see which adapters is based by default after the installation to this bonding. So in my example, we can see now that we have two 1 gig adapters and two 10 gigs adapters that connected each one of them, and it's based and active passive, and I will show you the options that we have on networking in the next slides. And we have the bridge BR0 that is the network of the connection between the CVM as the host, as I presented in the 192 networking connection. Once we choose the physical adapter, we can see what is the details of the hypervisor, the CVM, the IPMI, which bridges is built to, and which physical NICs is connected to this GUI. And everything is based on a command that's running from the CVM itself, that if we want to see it directly from the CVM, we can run a command, for example, that see host IPS or SVM IPS, and then I can see my entire networking. So by default, once I created and finished the installation, I'm getting the active backup mode of the networking. So we have the bridge 0, BR0, and we can build more bridges and after that with the GUI or with the CLI. Today it's also available to do it from the GUI, and we can start to build more networking connection on the top for different VLANs that will be presenting for VMs, for user data and everything. On the left side, again, we are seeing the internal networking connection between the controller VM, okay, and the host himself. As you can see, it's connected to ETH1 in the controller VM, and it's going directly to the host without any physical NICs. Okay, we have few options of networking connection. So first of all, it's mandatory and recommended to move out a few different links from the same bridge to avoiding performance issue. For example, if my active backup is moving to the 1 gig networking, and we can decide if we want to work with an active backup or balance SLB or balance TCP. And of course, every requirement also to do changes and in the switches if we, for example, go to a balanced TCP. If we will go to balance SLB, we can stay out without an LACP, and the OVS, the Open vSwitch that we are using, will know how to split the data between the networking, the physical networking switch. Also, if we want to see not in the GUI and we want to do these changes, so part of these changes today, if we want to do changes in the Open vSwitch, we can do a lot of that from the GUI already. But if we still want to do it from the CLI, we have a command from the CVM that's called manage OVS. It's API calls that we generated to avoid a lot of subtext commands. And we can, for example, do manage OVS minus bridge name, bridge 0, and show uplinks. And it will show us the the GUI vision of what we saw in the previous, and everything is running at the end and running on the background OVS VSEPL commands against to the host. Okay, so we can do it with the manage OVS, or we can do it directly with Open vSwitch commands directly on the host himself. Okay, and as also Tom said before, if we want to run a command that's going for all of the CVMs or all of the hosts, we have something that's called host SSH or all SSH. Host SSH, it's a command that if we will run, it will go directly and run it against the physical host and all of our hosts in the cluster, and all SSH is against all of our CVMs in the cluster himself. So let's go for the questions. For the first question, which of the following networking requirement is mandatory? Go free to answer in the chat.
We have a lot of B's, got a C in. And there's a big difference between mandatory and what would be possible and what would be recommended. So
yeah,
you need to read the question correctly. Well, we're all over the place, so there's a lot of different answers. So let's see what we wanted you to answer in the exam. A and B is one, some A's.
okay. So our answer, and the correct answer is B. Don't remove CVM from Open vSwitch BR0. This is mandatory. CVM must speak with a bridge 0, and this is a mandatory not to move his networking. Also, to move this networking is required to edit really the XML file of the CVM, and this is something that we are not recommended to do with any operation.
Yeah, important to know that the other answers, yeah, they're best practices that you could do, but it is not mandatory, right? You're not needed to move the NICs, slower NICs, but best practice would be that you, of course, do it.
Yeah. Okay. Next question, which 3 AHV bond modes can be configured?
Lots of ABD. Well, it has to be because balanced UTP, you tell me.
Yeah.
Yeah, we got everybody's answer in pretty much. So ABD was the correct answer.
Yeah. Next question, match CVM virtual NIC with their respective function.
Seeing a lot of CABs coming in. CIB being management connected to ETH0, hypervisor connected to ETH1 and ETH2.
Exactly.
So
that's ETH0, yeah, ETH0 is related to the management, ETH1 to the hypervisor, and ETH2 to the backplane to separate it if you want to separate the storage traffic. What command initiated from a CVM is used to view the physical NICs on all of the AHV nodes?
So this ties back to what Tom also discussed on which command is being executed where. That's the first thing that you should dissect from this.
Be aware it's nodes.
What do you want to know?
Yeah. And be aware it's tricky because it's going to the host. Okay.
We have B and C. People are a little bit divided between the two. But the majority is B. Oh, got a couple of C's in again. A and D. It's not a multi-answer.
Okay, so the right answer is B. Because we want to avoid too much SSH connection in both, it's like to do double command, and the right answer is to do it with host SSH.
Oh,
what is the proposal? Yep.
So I want to show you why are the others not correct. Well, we talked about the all SSH, right? Those are commands that are being executed on the CVM, but you're already on a CVM, so that doesn't make too much sense. The last two have the IP addresses in them, but what they do again is connect back into the second one is connecting back into the CVM, where the third one is connecting from the CVM back into the host. So that's a little bit of a loop around that you do. So the only one correct is B. Yeah, so that's how you dissect it.
What is the purpose of optional CVM interface ETH2?
Lots of A coming in. We have a single B, but the majority says A. So what do you think over here? Or what does the PowerPoint tell you?
I know the answer. So it's the traffic between, it's A, okay? It's the traffic between the CVM. It's the intra traffic between the CVM, and it's not between clusters. So for those of you that mixed, you say it's storage traffic between clusters. In the future, it will be replication traffic, but not storage traffic. Storage traffic will stay intra-cluster traffic between CVMs only. Which of these CLI command is not valid?
So the way to approach this is first, okay, is the command line start correct, right? What is it trying to do? Well, obviously it's looking to show you physical network connections in this case. So that means that you need host access. So that's the first thing that you can dissect from it and then work from there.
So the right answer is C, because as you can see, if you want to run something against 192.168.5.1, it's the IP address of the host in the internal networking. We can't start it with manage OVS. It should start it with SSH, and this is the mistake. Okay. Let's go over section 4. Feel free to ask more questions in the Q&A, and feel free. Okay. So once we want to create, and before we want to create actually a VM, we need to upload this image. Based on the AHV, we are not using like attach CD-ROM from the GUI. We need to upload the image for the image services that's based on the Prism element. And then we can actually deploy a new VM, deploying or adding, attaching the CD-ROM for an existing VM. So we are going to upload an image, and then we can choose if this is an ISO type or a disk type, okay? This is only for AHV, of course. And if we are speaking about ES6i or Hyper-V, we are staying with the default of this hypervisor. We support it, and we are taking this ISO and disk type and move it and convert it to AHV format, but we know how to get the format from RAW, from VHD, from VMDK, VDI, Oracle VirtualBox, ISO, and QCOW2. So all of these are valid type of drives that can be uploaded to an image services and created. Also in the image services, we will be required to say what is the image type that we want and on which storage container we want to put it. Additional option that we, instead of upload the file, we can give him also an HTML or NFS source to get the image from there. We also usually in a new cluster installation will created an image that created the virtual I/O drivers. Once we want to install Windows on an AHV cluster, we need to attach the virtual I/O drivers. We need it from the boot. Okay, so for example, if it's a fresh install of ISO, we need to go and use this virtual I/O driver for the boot. And this is usually on the right thing, you will see the drivers that require to be updated on the VM himself, Ethernet adapter, SCSI for drives, and virtual balloon drivers. Once we are creating a disk for VM, okay, we can choose what disk do we want and what is the type, what is the operation. If we want to clone it, for example, from just a file that we copy to the distributed file system, so Acropolis distributed file system, and what is the bus type. And the bus type is related to if we use a CD-ROM, we will use an IDE. If we want to use a disk and we have the drivers already installed in the VM, we can use SCSI. In the cases that we are doing some migration and we have issue with installing the drivers upfront, we can also create a disk, physical disk with an IDE, and then usually the VM will not require and drivers. Few important things of limitation, okay? Once we are using an IDE or a PCI, there is a limitation of devices that can be connected or attached to a single VM, and it's 7 devices. And if we use SCSI, we can use up to 256 devices to a single VM. Nutanix guest tools, we have created, and Nutanix guest tools that's relevant for VMs that running on Acropolis hypervisor or VMware. And with the guest tools, we are getting a few options that will be supported in the VM. We will speak also deeply, I think, more on the data protection about SSR, single service, self-service restore, or what in the previous it was called FLR, file level restore, that once we are installing the guest tools on the VM, it will share to the user that's running and log into the VM to see the snapshots that created and to restore a single file. We have NGA. It's the connection between the CVM to the VM himself. If we want to do like an application consistent snapshot, or we want to get more information about the VMs. And the NGT is also including with the mobility drivers, and if we need a multi-hypervisor environment, for example, if we need to do a replication from E6i to Hyper-V, or from E6i, sorry, to Acropolis hypervisor, or from Acropolis hypervisor to E6i, and we will speak about it on the data protection section. So on any VM, after we create it, there is a manage Nutanix guest tools, and we can enable it and decide what do we want. Okay. So the question is, what is included or enabled by the Nutanix NGT bundle?
Getting questions in, AD, AB, single A. So the majority seems to be consenting on A and D.
So the default one that installing over is A and D, exactly. Application consistent snapshot and mobility drivers. Second question, what disk format are supported by the image services?
Yeah, the easiest to answer this question is just find the one that's not correct.
Yeah.
Otherwise, you'll be staring yourself blind on all the abbreviations. Well, we got a mixed bag actually. D, C, B, got a couple A's,
Yeah.
so people are divided on this one, but there's only one correct answer.
Yeah, the correct one is, and I will explain. If I'm looking on A, we are not supporting UDF. Okay. If we are looking on a B answer, we are not supporting OVA. And C is the correct one. And in D, we are not supporting also, I think it's a VDI, no, OVF, sorry,
Yeah.
I missed it. I look for him actually, and I said where is. So we are not supporting the OVF format. Okay. And section 5 will speak about NCC and health and monitoring and alerts with our clusters. So part of the installation, we have something called Pulse. It's called home configuration. We are really recommended to any customer to make sure that Pulse will be enabled in his cluster. We understand that there is a few dark side, but we remember that we are not collecting any information about the customer environment. We are doing collection only about issues without, and we are clearing the data. And one part of this, we will get also the alert for us, and you can configure also for which user you want to get alerts in case of failures and everything. Based on that, all of the alerts is coming from a health check that we are doing, something that's called Nutanix cluster check, that we are collecting information. From a version to version, we are adding more functionalities and more checks that we are collecting today from the customer. And these checks can help us to determine and understanding issues before they're actually happening and coming to a bigger issues. We are collecting it in a few topics, on a VM, on a host, on a disks, physical disks, storage containers, storage and cluster services. And in the right side, we have an action. So by the default, there is a lot of checks that running and getting like their own schedule. But on a time to time, we fix our issue, or we want to check if this issue was fixed by a change that we have done. So we have an actions that we can actually run the checks by ourselves right now, and we can do run checks. And with that, we can ask the system to do a full check or only failed or specific check. And in the last and the down section, we can decide if we want to check and sending this report also by email or grabbing the information from the tasks. We have the tasks options, and then we can see this task and grabbing the information. For a lot of checks that we are running, we want to give the option to the customer to choose what is his parameters that related to him. Because we are seeing, for example, that customer utilization of 75% average and 90% on the peak, not always relevant to any customer. So you can easily update the information by yourself by this check, or doing a manually run for this check in case you have done any fixes. And you can do a schedule and decided if you want to change when to run this check. Okay. We created also analytic dashboard, and in the analytic dashboard we are collecting all of the alerts and the events and we are presenting it on the right screen all over the time. What is the analytics issue? What is the, if we had any alerts or events, and we can see how it's split across the one day that we are seeing. Now we are seeing, if you see here on the top right, you will see what is the time frame that we are seeing now. And with the red, with the blue, sorry, we can move out and scroll out once, or in which hour do we want to see our issues. And we can add more on the left side, and also with the new, we can add more entities that we want to see in our graphs. And it can be flexible by the user usage and what they want. There is also a small error here that I don't know if everyone know about it, that you can export the data to a JSON file or getting an HTML link to the same graph. And then you can actually getting the raw data information and the numbers. So what is the purpose of the NCC? Nutanix cluster check. It's a hardware log connected to any of the CVMs, calculate and reclaim space of the snapshot, or health check. Since it's a quick answer, quick question. Yeah.
A lot of people doing D.
D.
Yeah.
D. Yeah. So the right answer is D, health checks. Okay. So NCC is the Nutanix cluster check and is checking the health check of the system. The analytic dashboard allow you to create which two of type of chart. So I'm not sure that I top of it really deep. So I will answer if there is a mistakes after that.
We have a lot of A and D answers coming in. Well, it's a fairly easy question, of course, because yeah, an open support case is not a chart, and out-of-band management also is not really a chart. But it is important to to understand what an entity and a metric is.
Yeah, there is a big difference between them. A lot of time people are confused. So entity is something that we have in the cluster, VM, host, disk, memory. And metrics is an IOP, sequential read, and other things that's speaking about performance and that.
Yeah, so what you can actually do, for instance, say you want to see the IOs of a certain host, you would actually create a metric chart and then select all the underlying hosts. But if the other way around, you want to see the performance of a particular host, then you would choose an entity chart. So what is the thing that you want to see first? That's pretty much what you can determine. Yeah. Or what you need to determine if it's entity or metric.
Also, and we are not showing it, and I will share my screen with a Prism page for a second. Martin, we are okay with the time, right?
Yeah, you're good on time.
Yeah, okay. So I want to show you, and I'm not sure that everyone know it, and I want to show you something very small in my cluster. That a lot of graphs that we are seeing on the way that we are working, we can easily just add them to the analytic page. So for example, if I see this graph here, I see the blue arrow, so I can just push on him and say, hey, add this chart to the analytic page. Hey, I'm going now to see the VMs, and in my VM, I want to see how is it related and affected to entire cluster. So I can easily go and doing like a CPU usage and then the analytic page, and then it will just add it very easily, you know, to my analytic page, and then I can decide if I want to see it for later or I don't need it anymore. But here it's very easily to see it just more than 3 hours, and then I can see the graphs. Also, I can just like clicking in the mouse and see the black screen or a gray screen and getting zoom inside about it. So a lot of things that can make it also very easy instead of just adding it manually. So just a tip hint for those of you that don't know. We are going to a break now, Martin, or later? What is the agenda?
Martin, your microphone is off or something like that.
Oh, sorry, I wasn't on mute. Yeah, let's take the extra 8 minutes because we're a little bit early. We should be, normally we should end at 11 for the break. So let's take the extra 8 minutes because it's a lot of information, and we'll resume the session at 11:15.
Okay. Toms, you want to share it, your screen?
Yep, I'll share.
And of course, don't forget to grab the keyword, number 2. So see you in a bit. Okay, 11:15. Welcome back, everybody. Tom, the floor is yours.
All right. All right, so we should all be good to go then. So section 6 that we're talking about now is all about the storage fabric, or the DSF. So to get started, the first thing that we'll dive into is everything that we might have touched upon briefly in the past, but is storage containers. So what we said in the past, or what I highlighted in the past, is that obviously we had a number of nodes. So you'll see these at the top. Each node running its own CVM, running its own set of, call it, local disks. So they are all aggregated together into a storage pool. Okay, and it's in this storage pool that we are creating multiple containers. And as you'll see, the orange, green, and blue one, we can basically set all, call it, specific metrics or options, if you want, on each individual container. So we can decide per container what options we enable around compression, dedupe, whether we want, I would say, an RF2 container, an RF3 container, depending on the amount of nodes, obviously, that we have in the cluster. If we need to whitelist a specific container to the outside world, etc. So every, I would say, option that we have can be, I would say, individualized per container that we have. And now we talked about the write paths a little bit in the past as well. So if we dive a little bit deeper into the write path, and more specifically how ILM is happening. So ILM stands for the informational lifecycle management, and how data is, I would say, traversing from SSD to HDD. We see that obviously when a user VM is doing some write IOs, it ends up at the CVM. So we discussed in oplog. Where is that oplog? Well, in theory, on its local SSD. Okay, so VM is writing, or CVM is writing to its local SSD if it's not full. If that local SSD for some reason would be full, the CVM is writing to a remote SSD. Okay. And as you've seen in my very small Prism demo, we first fill the SSD tier until, I believe, something like 75%. and only then we start draining data or migrating data down from the SSD tier over to the HDD tier. So that's what you'll see in these screenshots. Now, what is important here as well is that we need to keep in mind when we talk about ILM, the difference or the attributes around resiliency and data locality. So resiliency is really the writing of multiple copies of data. So one copy local, one copy remote somewhere. Data locality is really the idea of having the data local to a node and reading that data locally from the local disks. So something we see over here, let's say we've got a specific VM doing some IO, and that IO would be, I believe, the yellow block, the green block, and the orange block. So as you see, step number one, it is doing some normal IO to its local CVM, okay? So these blocks end up local, I would say on the local disks to that VM, and they are sent to a different node within the cluster. If we then would move that VM, step number two, towards a different host, let's say host number 2, if that VM is writing new data, okay, step number, let's say, 3A, obviously we resume IO. Step 3B, we are writing new data, again, local to that node, okay, and somewhere else in the cluster, in this case, node number 3, all right? What is happening in the background, because this VM has migrated and is obviously doing some read operations later on, as time goes by, step number 4, we are moving data back local again, but only the blocks that we are reading. So let's say a VM has a couple of blocks. The blocks that he is not touching stay remote. They are not moved. So only the blocks that we are actively reading and writing to end up local again. All right. So that is how I would say data localization, ILM, data locality work in the background. When we then start to talk about some optimization features that we can implement, there's a couple of them. I would say number one is compression. Okay, I always talk about making some, I would say, zipping some data to, I would say, make more space at the DSF, but it's effectively so reducing the number of bits and individual chunks of data. And there's a couple of ways how we can do this. You might see that later on. But data can be compressed as it's written, so inline compression or post compression. Okay, so those are two options there: inline compression and post-process compression. Other, I would say, optimization technique that we could enable is deduplication. Okay, speaks for itself, eliminating, I would say, redundant data. So if you write 2 times the same block or have multiple, let's say, VDI images where the Windows base OS is identical each time, this could be, I would say, could be, but you'll see later on an example of deduplication. Obviously, deduplication is something totally different than compression, and only one unique instance of that data is retained. The others are replaced with a pointer copy. How does the compression work? So again, you'll see here the two differences. Inline compression, extremely fast algorithm, LZ4, that we're making use of, and upon ingest. So once the data ends up in uplog, that data gets compressed, okay? Post-process compression is that we are writing the data uncompressed, and later on we are, I would say, compressing it once it's in extenstor. Okay. Moving on, I would say a third technique which exists in reducing data is something we could call erasure coding, or ECX. And effectively, I call it, it's similar to call it rate technology. So what do we have here? In this case, we have some blue data, some green data, and some purple data. So let's say our, call it unique copy or first copy is our green data. So that's the one that's our first written copy that we want to keep or that we're keeping. And we have, call it blocks A, B, C, D, E, and F. So 3 copies of data, RF3 in this case. So what is happening with ECX is that we can basically take away copy number 2 and copy number 3 of that data and replace them with parity blocks. Okay, so let's say this is stripe sets. A, B, C, D is a stripe set. We can put in parity blocks. And once that is the case, we can take away the secondary copy and the third copy of that data. So keep in mind, we still are fully compliant with RF3. Okay, I can still lose 2 nodes into my cluster. So I can lose node number 1, node number 2, for example. So the first 2 nodes in my graph. Okay, and I can still fully recreate the ABCD pair by having block A, block B would be my parity, C and D. Obviously, you'll see that we need to go through some calculations to recreate block B. So an erasure coding set has some kind of, call it penalty in case of failures that you need to recalculate a specific block. All right. Putting them, I would say, a little bit together from a deduplication and compression point of view, some best practices. What do you come across? Well, you'll see a number of use cases, so-called user data, VDI, data warehousing of, I would say, huge amounts of data, etc. With some file server with some examples around file servicing, and you'll see what is the, call it, recommended. But don't take this for granted every single time. It's a recommendation to enable, I would say, a specific methodology of compressing or deduplicating data. Obviously, all depends on your use case and the amount and specifics of data that you have. Simple scenario I always give is that, for example, you see a file server which has lots and lots of JPEGs, for example. If it's only photos, the chance that you will be able to compress something is small. JPEG is already a compressed format, but all depends on what you're storing, what the data is, what your possible gains might be there. All right, so moving on to the first set of questions around the DSF framework now. So already again, number 1, where is our oplog located? Is that on HDD, SSD, on our DISCON module, or is it in random access memory?
Everybody seems to think B, Tom.
Are they right?
Well, you tell me.
Yeah, they should be right. B is the right answer. For some reason, this
answer slide
slide missing with the correct answer, but it is indeed the right answer here.
I'll fix the deck.
For some reason it got mixed up in the slides. So B is the right answer. All right. So question number 2 or 1 in this case. Which 3 storage containers are pre-created after foundation or after installing a cluster? I mentioned this and I even showed this in the Prism demo, I believe.
ABC, ABD, ACD. There's a couple here. ABC. Well, it's actually easy to just get the wrong answer out, right?
Yeah, it's fairly easy to find the wrong one. A Prism central container is not something that really exists. So the correct answer here is we create by default a self-service container, a Nutanix management share, and then a default container with a generated number behind it. These are the defaults, but again, as said, you can create your own containers, and each of the containers can be set with your own sets of data compression, replication techniques, etc. So going to number 3 here, what optimization features can be configured at the storage container level? And you can give multiple answers.
We have A, C, and D. We have A, D that some people give, but the majority looks to be A, C, D. I see some ADs, I see an AC. So there are some different answers. So that needs some extra explanation, I think, Tom.
Yeah, so the 3 options that you'll have, or you can basically, another option would be to look at which could be wrong, but the 3 options that you can enable on a storage container is obviously do deduplication, okay, do erasure coding as explained, and do compression. So 3 storage reduction functionalities to save you on storage space instead of writing, I would say, RF2 or RF3, 3 times data, methodology of reclaiming some space here.
Yeah, and B, the video stim provision is actually, it's always on. We always stim.
Yeah, it's by default.
By default, you cannot turn it off. I wouldn't know why you would want to turn it off anyway. All
right, now, tricky question.
Oh,
a cluster running RF2 has 5 containers configured. Each container has 20 gigabytes. There is no reserved capacity. So what's the size of our storage pool?
We got some D's, we got B, we got A, so
we're all over the place.
Everybody, we have them all. So this is quite a formula that's behind this, and there's some clues in the question that are really important. So don't read this one too quick. Really understand why a certain metric is being given here. So walk us through the answer, Tom.
Yeah, I'll try to be as complete as possible. So this is still the easy one. There's a much harder one coming after this. But what do we see? We see that we have an RF2, okay, which means that I need 2 copies of the data that I'm writing. Okay, we see that I've got 5 containers, but by default, when you create a container, it takes up just the amount of space that there is available. So as long as you don't put any reservations, a container consumes as much capacity as there is available. Now, what do we see, or what have we said? It is consuming 20 terabytes. So what can we, I would say, do with the numbers that we have available here? So 20 terabytes of data that can be used in an RF2 format means I need 40 gigabytes. Terabytes, sorry, yeah, indeed. I'm still living in the old world, so I'm still in gigabytes. All right. Anything you would like to add, Martin? But I think that's roughly the calculation.
The 5 containers here is one to throw you off a little bit. And like you said, if you see the containers 20 terabyte and nothing is reserved, that means that it's the max. So RF2 times 20 terabyte is 40. That's the simple calculation. Yep. Yeah.
All right, next one. This becomes a little bit harder, and you've got a little bit more time here. But so, a cluster is running RF3 cluster. I've got 5 storage containers again. My storage pool is 15 terabytes. Now, after this, I am even adding 2 more containers, container A and container B. And for these containers, I am reserving 1 terabyte of capacity. So now, what is the raw capacity of these 7 containers?
We're getting a lot of D's in the answer box.
All right.
So give it a little bit more time to land with everybody. And it needs a hefty explanation. Yeah, seems like we have consensus on D.
Consensus in D?
Yeah, I haven't
Okay.
seen the other answers yet, so.
Yeah, they're probably all answering D because they've seen one guy answering D.
No, probably not.
So D is the correct answer. So what's the math behind this? Really quickly, I don't want to go too much into depth, but what do we see? An RF3 cluster, which means I've got 3 copies of data. I know that my storage pool is 15 terabytes. So that means if you do a quick calculation, 15 terabytes divided by 3, because I need 3 copies of data, that means that typically a storage container would be 5 terabytes in size. That would be a typical one. Now, obviously, we are mixing in 2 new containers, okay? And we said that they needed reservations. So we are really blocking 2 terabytes of capacity for these new containers. So which means that the normal 5 terabytes of capacity that we have for our containers, we need to subtract 2 terabytes so that the normal capacity becomes 3 terabytes for our, call it original containers, okay, that they could use. And containers A and B are basically our original capacity, 3 terabytes, plus their 1 terabyte of reserved capacity that we set for them. That's the math behind this. All clear? All good?
Yeah, well explained. That's how it goes.
All right, last question of this section. What is the minimum amount of nodes that we need for a non-robo, so a typical normal cluster with RF2 and erasure coding enabled?
We're getting a whole mix of answers, C, B, D, C, D. So we need to do a bit of explanation on this one as well.
All right. So the correct answer here is number, or obviously number C, 4 nodes. So what do we need? Obviously, to get started, we'll need 3 nodes as a minimum, because we're talking about the non-robo scenario. Typical, I need 3 nodes to form a cluster. Okay. But when you enable erasure coding, when you look at how erasure coding works and to put everything to work, you'll need at least, I would say, 1 extra node to put your parity on, basically, and to make your stripe size in order. So if you enable erasure coding, the minimum amounts of nodes you'll need in an RF2 scenario is 4.
Yes.
All good. So then we move to the next section, which is all about migrating workloads. So if we want to start migrating workloads to AHV, there's a couple of options that we have. You could do something manually, depending on what your source or your destination is. You could make use of third-party software. You could maybe use cross-hypervisor DR. I would say you could use Nutanix Move, or what we formerly called extract for VMs. Or in some case, you could even go for something we call dial, which is an in-place, I would say, ESX to HV cluster conversion. We're not going in depth on all of these methodologies. Know that they exist. Know that there is something like dial, that there is something like cross-hypervisor DR, where obviously if you want to make use of cross-hypervisor DR, your source target needs to be a Nutanix cluster. So that means a Nutanix cluster running ESX, and your destination at that point is a Nutanix cluster running AHV. So you can do protection domain setups between them and replicate data that way. If you choose for a manual method, what are the steps or things that you need to take in mind, or what you need to do to make sure that obviously things work? On your source, I would say, Nutanix environment, or in your source, you'll need to make sure that you have the VMware tools installed, which you probably have. You'll need to make sure that you have the Nutanix mobility drivers installed, so that at least your VMs, once they need to boot, they understand what our SCSI controllers are, what our network interfaces are, etc., so that they have the necessary drivers on board. Next, what you'll need to do is make sure that you'll need to add this ESX host to the whitelist of your AHV container, so that the ESX host is now seeing your AHV container as an extra data store. So that is what you need to do there. And then obviously you need to migrate your VM with, let's say, storage migration from ESX to AHV. And you might need to build your new AHV VM using the flat file on the AHV site. Okay, so these are the manual steps that you'll need to take when you need to migrate a VM from ESX to AHV. Okay, there is obviously a much more, let's say, automated action, which is, I would say, what I would prefer, and that is making use of Nutanix Move, or the extract for VMs. So what is Move doing? Move is basically taking all the previous actions that you had to do manually, doing it on an, let's say, much more automated way. And I would say even across, I would say, not only ESX, but also from an Hyper-V, also from an AWS source environment. Simply said, what you'll do within Move is you'll say, which is my source environment? You hook it up to your vCenter, to your ESX environment, to your AWS console. And from there on, you start to create a plan, okay, from where you can say, I want to start specific migration for a specific VM, for a group of VMs, schedule migrations. And then what happens in the background is that data seeding starts, but the original VM keeps on running on its source environment, okay? But we are already seeding data to the Nutanix cluster until the point that we have, let's say, 99% of all your data. At that point, we come to a cutover phase at which we can shut down the source environment, migrate the last delta, and boot up your, let's say, new VM or migrated VM on the AHV side, okay? So that is really in a nutshell on what is happening on the Move side to do some migrations there. Obviously, there are some, let's say, requirements. Your VMs need to be certified on AHV. For a list of, I would say, certified OSs, I would say take a look on our support portal, but there's a lot that just works outside the box. So a couple of questions, again, related to migration workflows that you'll need to keep in mind. When you would do a manual migration of a Windows VM, what are or what could be prerequisites? Again, multiple answers.
AC, A, C, and D. I got an A, B, couple of them. So we have some mixed answers.
All right, so the correct answers here are A and C. All right, so we need to make sure that we're removing hypervisor-based snapshots. Okay, these only cause problems during migrations. CD-ROMs is absolutely no problem. By default, they are configured on an IDE bus. They can just continue to be there. But if you do a manual migration, your VM must be powered off, because you must be able to, let's say, manipulate the disk and move the disk of that VM. And there is no such real limitation if you do things manually around only 10 VMs or something like that. So question number 2 here.
In the chat that I'll answer live, and then why is
okay.
answer not included? That's pretty simple because the CD-ROM doesn't have to be removed. It is something different if there's a virtual ISO in it. The actual CD-ROM drive does not have to be removed. So I hope that answered that question.
So the device itself can perfectly be there. But obviously you'll need to make sure that there is no ISO attached or something like that, because that again would cause issues. So question number 2 here, to build a VM on the AHV cluster after migration, what options do you have? And I think Ophir maybe even showed it during one of his screenshots. What at-disk operations can be used? So how can you add a disk to a newly created VM?
So I see some answers come in here. A and B. We got an A and D. We got AB, more ABs.
ABs?
Majority seems to be AB.
Well, that's right. They paid close attention, I believe. So the 2 options that we have is we can clone from the image service, call it an image library that exists on the Nutanix side, or they can clone an existing file, at which point they need to point to the exact file path to clone that file. So those are the 2 options available there. All right, so moving on to section 8, which is around, I would say, Acropolis storage services. So which additional storage services do we offer next to call it VM storage? And the first that we'll discuss is Nutanix Volumes, which you might remember from the past as ABS, block storage. But so in the meantime, we all speak about Nutanix Volumes. What is this? Well, it is nothing more than the ability to enable, I would say, access to the Nutanix system over iSCSI, okay? And this access is delivered by the data services IP, okay? And what we're doing with Nutanix Volumes is presenting LUNs to either VMs or to even bare metal machines. So it delivers us the ability to deliver a resource to even the outside world, outside of Nutanix, where the data of these physical servers can reside on the Nutanix system. So think about an Exchange server or an Oracle server or a SQL server where you want that data to be located on the Nutanix system. Now, an important one where Nutanix Volumes is used quite a lot is in the case where you'll need to have or offer a shared disk to multiple VMs or to multiple bare metal servers, like a quorum disk in case of clustering, etc. So that is the use case where this is used quite a lot. One very big remark, please never ever present this, let's say, volume to the hypervisor or to an external hypervisor as a data store. So never create a volume and present this to an ESX host running next to your Nutanix cluster as the data store for its VMs. This would have a call it negative performance impact due to the nature of how this is happening underwater. What is important here, how are we, I would say, attaching these volume groups to our VMs? Well, basically, obviously, on the Nutanix side, you create a volume group, okay? In that volume group, you'll create a number of vDisks. So similar like you would create a traditional VM, which has a vDisk. A volume group has a vDisk as well. And obviously on the host side, on the physical or on the VM side, each of these machines or Windows instances, for example, has an IQN, an identifier of that image. And we'll specify, I would say, by the combination of both, how we're accessing that data. From a security point of view, as we're talking about iSCSI, we can make use of CHAP authentication and these kind of things here as well. How is the connectivity happening? So high-end drawing here. So we've got a VM which would like to access basically a number of disks over a volume group. Its local probably software iSCSI initiator, is targeting our data services IP and says, I would like to log on and access my disks, okay? That data services IP comes back to the iSCSI initiator and says, well, you can now start to talk to, for example, CVM1, because he's the owner of these specific volume groups or these specific disks. And at that point, our VM is starting a direct conversation with CVM number 1. Okay, so that is how a typical connectivity is going. If for some reason, okay, there would be a scenario where CVM1 becomes unavailable, okay, what is happening in the background is that obviously our iSCSI initiator is seeing this, is directly again talking to its data to the data services IP of the cluster. Okay, we'll see in the background that the ownership of our volume group number 1 has transferred to another controller VM. So the data services IP comes back and says, well, you now need to talk or do a redirect to CVM number 3, and we are again remounting re-talking to, in this case, controller VM number 3, accessing that same data, those same vDisks that we had in the past. So it is fully transparent to, let's say, the end user. This just happens in the background fully automatically. Okay. Anything you would like to add here, Martijn? But I think it's pretty obvious from a drawing perspective.
Yeah.
Yep. So moving on, Nutanix files. What is Nutanix files? Well, again, it's a, call it, virtual file server that we spin up, leveraging, again, in the background, our DFS, okay, as our, let's say, high available fabric. In the background, we're spinning up a single namespace hosting home directories, file services over SMB or NFS. Okay, you'll see the specific versions listed here: SMB 2, 2.1.3, and from an NFS perspective, 2.2, 3.0, and 3.5. Sorry, 3 and 4 for the specific support here. What else is important is that once we create a file server, okay, it basically in the background creates multiple FSVMs, file server VMs, with a minimum of 3 again. So similar, like I would say the CVM perspective, we create multiple of these FSVMs to handle failures. And each of these FSVMs then becomes, I would say, the owner of specific folders or directories, depending on what you would create. What is the minimum, or from an IP perspective, what you come across? The minimum number of IPs that you'll have is 7 if you deploy a file server instance. Why is that? We require 3 front-end IPs, basically to talk to the client world. We require 3 back-end IPs to talk to, let's say, our CVMs, okay, so call it the storage backend. And there is 1, call it virtual cluster IP being used, or file server cluster IP. And I believe this is the one that they're referring to in this scenario is more the data services IP. But correct me if I'm wrong. If for some reason there would be need to, I would say, scale up, scale out, these again are options built into the Prism menu. Take a look at demo.nutanix.com if you want. I believe you can look into the file server menu there, but which options you have from a scale up and scale out perspective, adding CPU, adding more FSVMs, changing the network. It is all driven again from within Prism, okay? From an authorization and management point of view, you can basically fully leverage Active Directory. If you're making use of SMB, I would say that would be even logical. Making use of AD authentication. Obviously, you'll need a user account with high enough domain privileges to deploy your file server, because we're fully registering this within AD. And you can make use of a special snap-in from an MSI perspective to manage your file server. So where you create your top level shares, setting the necessary permissions, etc. And so you can do the necessary downloads over support portal. So from a configuration perspective, going over, I would say the last number of things. So minimum number of 3, the minimum size, I believe, minimum 4 vCPUs, 12 gigs of memory per file server. You can change network configuration, guest network, storage network, again, fully from within Prism here. Going to the next set of questions. Ready? So here we go. Question number 1. How does the external server, so in the case of volume groups, how does an external server, your client, gain access to the disks in a specific volume group? Multiple options available here.
We have a AC. I see a CB, but the majority seems to be A and C. One more B.
A and C.
Let's see, an ABC. We have,
Yeah.
but the majority.
The right.
AC.
Yep. Okay. So the right one is obviously A and C. I can add the client's IP to the volume group whitelist, or I can add the client's IQN, its identification number, basically to the volume group's whitelist. Both are possible there. Number 2, Nutanix Volumes, okay, facilitates the support for which of the following use cases? Again, multiple answers are possible.
We got an ABCD, an AC, an ACD. We got an AC, a BD, ABD. So we have a mixed bag of.
A mixed bag. All right. So
somebody saying all. Yeah, we count that as well. So, but it is all.
it is all. I can use volumes for iSCSI for an external iSCSI or even a VM Exchange server. I can use it as shared storage for Linux clusters. I can use it for Oracle RAC environments. And obviously, as said, I can use it for bare metal environments. All right. Which of the following statements are true for Nutanix volumes? Again, multi-answer.
So what is true?
What is true?
But the answers coming in, A and C. You got an ABC, we got an AB, more AC. We got an SC, but I guess that's a typo. It needs to be AC. Yeah, why do they put that S so close to the A? I don't really get it. So.
All right, so the right answers here are I can make use of CHAP from an authentication point of view, and Nutanix Volumes is available for ESX, AHV, and Hyper-V deployments. So I can use it on any kind of, I would say, virtualization layer with Nutanix. Multipath IO is perfectly supported. Okay, so that all depends how you create a volume group. If you create it, I believe, from within the GUI, it is talking to one CVM as explained in the diagram. If you create it from within the command line, where we can leverage, if you set the parameter right, with full multipath IO talking to all CVMs to give you more bandwidth. Last question here, which features require the data services IP?
ABC, BC, BC, more BC, another ABC, but B and C seems to be the prevalent answer.
Yep, B and C are the ones that really need the data services IP. So microsegmentation, absolutely not. and Nutanix disaster recovery, I presume we mean our protection-based or protection domains with that, or async replication, etc. Again, there is no data services IP needed for
No, it
that.
actually uses the cluster IP.
Yeah, cluster IP for that.
Yeah.
So volumes and files are the ones that we need a data services IP for. All right, so moving over to next section, which is resiliency.
You got 10
Again,
minutes
very
for-
short one.
Well, it's a short one, so it's okay.
It's a short one. So what is important here? Resiliency by default, okay, by default HA is enabled. Okay, so there is no extra checkbox that you'll need to make. By default, high availability is enabled, but you can enable high availability, as you'll see in the screenshot, to make sure that we reserve the necessary space on the cluster so that we can ensure that in case of a failure, your VMs get restarted. So by default, it's a, how do you say, best effort handling. If we have resources available, we do a restart, okay? If you enable this feature, you are guaranteed that all VMs will restart in case of a failure. What else do we have or can enable again on the HV side then? That is affinity. So basically saying or calling pinning VMs to a specific host. So I can do this from within Prism, as you'll see, and say, well, a specific VM can only run on maybe 2 out of 3 or 3 out of 5 hosts, depending maybe for licensing reasons or whatever. So I can set this affinity per VM from within Prism and obviously from within the ACLI. Okay. Obviously, this is affecting migration options. In case of failures, we are granting, I would say, this, let's say, affinity. So let's say node A, let's say node A would fail in our scenario. The restart of that VM will happen on node B, okay? So that is the affinity. What is anti-affinity? Something we can set as well. Anti-affinity is a VM to VM anti-affinity, okay? So pay close attention when we talk about affinity, it's about a VM to a host. When we talk about anti-affinity, we talk about between VMs, okay? This needs to be done or can only be done through the CLI, okay? Anti-affinity is not available yet from within Prism. Anti-affinity makes sure that we have VMs running on different hosts. We can place them in a group, and as such, I would say move VMs out of each other's way so that they don't run, I would say, on the same host. Can be done again while VMs are online. Last but not least, when we talk about, I would say, resiliency and that kind of things, awareness levels. So depending on what you select, so we talked about nodes, blocks, and racks, or not so much about racks in the past, but so depending on your replication factor, whether it's 2 or 3, what are the minimum of nodes that you'll need in which scenario, okay? And so basically, how many failures can you tolerate? And an easy, I would say, formula is take your RF factor. How many copies of data do you have? -1. That's the amount of failures that you could tolerate. So in an RF2 scenario, I could basically say I can tolerate 1 failure. Okay, you see the graph later on, depending on a block setup or depending on a rack setup, the amount of nodes that you might need as a minimum, and what your resiliency in that case could be, so your cluster is kept alive. Now, what happens in case of failures? So typical condition that we see here, I've got a VM running on node 1, talking to my local, I would say, controller VM, talking or writing locally. I've got a secondary copy of that data in my cluster. If for some reason I would lose that host, okay, the node or host becomes unavailable, that VM is restarted automatically. This is no, call it Nutanix magic. This is just the hypervisor doing the necessary things with HA, okay? But we can reboot that VM because we still have a copy of its data somewhere else in the cluster. Some blocks might be local, some might be remote, yeah? But directly our DSF and the controller VMs see that they only have one copy of that data, so they will directly do the necessary to make one data local again to that VM on read and write operations and create a secondary copy somewhere else in the cluster so that we're fully protected again. Okay, so that is most important here to mention. Failure scenario number 2, which you could run into, is CVM resiliency. So by default, again, guest VM is doing IO to its local controller VM. They're kept in sync over, I would say, the network that we have. If for some reason the local controller VM would become unavailable, obviously our inter-CVM connection detects the loss and sees that node 1 cannot talk to the rest of the cluster anymore. What we're doing in the background is injecting a route into the network of the hypervisor so that it can now talk remotely to another controller VM. And again, noting that the guest VMs see. So guest VMs are not impacted by this. They keep on running. They can keep on accessing IO. They still have their data available. The CVMs are seeing this and again, fully reprotecting and making sure that they have 2 copies of data again. All right, these were failure scenario handlings. So last set of questions here for me. What or through what interface is or are anti-affinity rules configured? So pay attention, affinity, anti-affinity, and what we just discussed.
The majority seems to think it's B and C. We also have an A, B, and C.
Yep. So the correct answer here is A, B, and C, because obviously I can set affinity, so VM to host over the CLI, but I can as well do it from within Prism. So C is a correct answer as well. And obviously the anti-affinity can only be done from the CLI perspective. What is the fault tolerance related to RF3?
Yeah, that looks like a question nobody will answer wrong during the exam if it pops up, because everybody saying C.
All right, so C is the correct one. That's a good one. Question number 3, what applies to VM high availability? Multiple answers available again.
See some C's coming in, B's, but a lot of B and C. An A and a B, more B and C's. I think the majority thinks B and C, Tom.
Yep, all right, so the majority is right again. So when we enable VM high availability, VMs are guaranteed to restart, so that's correct, B. If we have nothing set, we are reviving them on a best effort basis, so C is correct as well. I've got no clue how VMs, when they are deduplicated, remaining on the same host in the clusters has nothing to do with high availability in my perspective. And A, if disabled, VMs cannot be migrated and restarted. Again, nope, that's nothing like that. We have enabled it by default. There is nothing that you can really disable on a high availability feature.
So you can just say we switch the behavior of HA. We don't actually turn something on or off. We just make it better.
All right, question number 4. What is the result when a CVM becomes unavailable?
We got a lot of A. We got a single C.
All right, so the correct answer here is A. So what we're doing effectively is we are changing from the host where the CVM failed. We are changing the routing table of the host, pointing to a, I would say, new or other CVM somewhere else in the cluster. And a way to maybe even visualize this is try to remember what Ophir said or mentioned with the networking. So the 192.168.5.1 and 5.2, the 5.2 being the address of the CVM, where you're basically telling the host that he can reach 192.168.5.2 over a new or other public IP address of an other CVM. That's what's happening underwater. All right. All good.
Small break before we switch it over. So let's make it around number 12:15. And then Ophir is going to take us through the last couple of sections. And don't forget to pick up the word again.
There you go, Ophir.
Yeah, thank you. I will share my screen. Let's take additional few seconds and we will start in 16.
Yeah, you're good to go, Ophir, whenever you're ready.
Okay. So I hope we take a good break. We are in the last section, in the last part of sections and of information that we are going to speak. And our first topic about it is data protection, and we will take the entire options and see what we have. So today, with every cluster, of course, we can do like a local snapshots and everything, but we have also multi options, multi-site async example, or async plus sync replication. Plus near sync replication, and I will touch about it. So in my example, and be aware that if we are doing a multi-site replication, it means that we have more than one remote site in the cluster. We need to get an ultimate licenses, okay? But today we can do from up to every few seconds until every day, Nutanix replication. Until 60 minutes, it's called near sync, and after that, it's called protection domain with async replication. And of course, still only with VMware, we always have the option of metro availability, and I will enter now and speaking about all of the options that we have. So I will start with the first one, synchronized replication based on storage container. Okay, if I'm comparing it to a regular protection domain that's usually based for VM. If we are doing a synchronized application, it will be based on a protection domain. Okay, so it's a real-time replication data between the sites. It means that any block that will be written before we getting the acknowledge, the data will be written on two of the sites with replication factor 2. So, or 3, of course. So we have, for any type of block of data, we have like 4 copies. And we have 3 options to a failure modeling, a failure handling option. And this can be decided for any customer by himself. We have one option that manually by user. So we are saying, in case that I have a networking issues, both of the sites will stay individual and you will not be able to write a new data, okay? And then a user need to come over inside to the system and decided that is breaking the replication. We have an option that's called automatic resume, that in case that we have like a networking failure, it will break the line and every cluster will be by itself and the customer can be written and continue to work. And the third option that is most recommended in synchronized replication at all is to use and to use with a witness VM. That with the witness VM, we should put it on a third site, and then he should see both of the clusters and he's monitoring the systems. And then you know if we do like need only to break the networking or to break also the storage container and move it to the standby site. Everything is based on that. So how it's working, synchronized and asynchronized data replication. We have a protection domain. A protection domain can be only local, okay? And it's not mandatory to be also by remote. It can be only local for local snapshots. It's based on a VM, okay? On a VM, I can decide also that I'm doing a consistency group for a few VMs. And I can do the following task, okay? I can do a take snapshot. If I'm involving also a remote site, okay? So I can do also migrate, update, and delete commands and tasks. And I can move very easily between clusters. Be aware, this is not based on Leap. If we already, and you hear about Nutanix Leap, this is based on Prism Element, the doing protection domain, okay? And you can do here a planned failover with the migrate option, okay? Or activated in the remote site in case you have an unplanned failover. But you should be aware that this is not involvement of IP addresses or VM changes. This is moving the VM as is and doing a registry to a vCenter or registry to Acropolis hypervisor on the remote side. It will not power up the VM. Once we are doing the migrate, okay, so the migrate will shut down and remove from inventory, okay, the VM. And again, as I said, register it on the second side. And once the production site is returning over, you can do also migrate back. In case the source site is failure, okay, you can do an activate, and activate will take the latest snapshot that we already replicated and promote it in the remote side. Be aware that in this situation, once the production is returning, both of the sites will be active, okay? And you should take care about it and return it correctly between the remote site to the source site. We have the option in the protection domain to do something that's called consistency group. For those of you that don't know, for example, if I have like a SQL cluster or I have like SQL plus IIS or some application that requiring to get a snapshot on the same time, we can do something that's called consistency group, okay? And it's created with the protection domain, okay? And it's not related, of course, to the boot order. It's just the time that will be taken to taking the snapshot exactly on the same time that will be exactly same files and everything. So how we created a protection domain, okay, and the schedule, we're actually going to the protection domain tab, and we are doing create a new protection domain, and then it will ask us what VMs we want to attach to this protection domain, and then we can apply a schedule about it. In the schedule, we can see on the left, okay, that we are sending and saying how much time, what is the retention, or in which specifically day on a week, okay, or day in a month we want to do it, and what is the start time. A few important, for me at least, we're just creating it and we're never seeing that the start time is now, okay? So if you want that it will start in the future, or the schedule will be, for example, always on 10 p.m., please be aware that you need to change here the hour for 10 p.m. And you can decide it also on an end time about it, okay? In the retention policy from the right side, we can decide that we can decide how much snapshots we want to save on the remote side, okay? We can decide it on which remote site we want to do the replication for this, and how much average of snapshot we want to save on that. After that, or before actually, if I'm comparing it to the right interaction or right creation time, we have also something called remote site. In the remote site, we are building the connection between the source and the destination network clusters, and it needs to be configured if we want to start actually the replication, okay? And remote site should be configured in both of the sites if we want to do the replication, okay? Otherwise, if we don't have remote site in both of the sites, the replication will not start it. We are doing source cluster to destination cluster on the networking, on the vSwitch level, and on the container level, okay? What is the source of the container? What is the destination of the container? And we need to do it the opposite way on the destination. As I said before, we have something in the few last releases, we have something called near sync, okay? Near sync, it's between 1 minute to 15 minutes. It's the average of the snapshot. For example, if your customer can't do a sync replication and because of latency on the line, so we can do also something that's called near sync and doing recovery point, okay? And it's something that's creating lightweight snapshot, okay? And it's replicated after that to that. We can do 10 VMs per protection domain, and it's supported only on 40 terabyte nodes, and the minimum is 1.2 terabyte of SSD, and minimum of 3 nodes cluster, and it's supported only AHV and ESXi, okay? And on a regular basis, okay, these changes of the lightweight snapshot will be consolidated onto a regular snapshot on the remote cluster, okay? And removes the lightweight snapshot from the uplog and free the SSD resources, okay? Practice questions, okay? So what is the result of a PD activate?
Yeah, we didn't really dive too much in it, but there's two things, right? You have an activate and a migrate. You need to be able to really understand the differences between the two. So let's see what
migrate is. If migrate is if the source cluster is okay and you want to do it as a planned, and activated if it's unplanned.
Yeah,
of course.
So we have a lot of D's coming in. We also have a B. I saw a single A coming in. So it's important to understand because there's some other actions that can happen as well, especially when you do a migrate and do an activate. So, but the majority thinks D, Ophir. So what does your slide say? What do you think?
So the slide is saying D. I will just add the slide. Sorry, say A. And this is of course if I'm doing it in unplanned. And be aware it can make you like a split brain and stuff like that. So it's something that you need to be considered before you are pushing the activated. Actually, I don't know if you play with that, Martin, but lately you should add like an answer. You just can't push anymore, just activate. Okay.
Well,
So
the result of the what is the result of the action that you do. So if there's indeed a split brain, so if one side is down or the network is down, and you don't check if the other one is actually down or still up, and you click activate on the second one, that means that at that point in time you have two active sites. So you got to be very mindful what happens if you join them back together again. So the first thing you should do is check, is the other side still active, or is it okay that I activate this one because I'm going to take down the other side, right? So that's an important one. If you would do a migrate, then we would actually fail over the VMs and actually automatically take offline the other side. Then it's an automatic process. But if you do it manually, you always have to think, okay, what is going to happen with the other side? And am I going to bring them back up together by accident if I don't take care? So let's give this one some attention.
Yeah. Which of the following statements is true? All replication require protection domain. Only asynchronous replication require protection domain. Protection domain require consistency group. Only synchronous replication require protection domain.
Yeah, this question is actually easiest to just find the false answers, right? So if you just eliminate the fact, so a consistency group, for instance, if you think about it, is an option, right? But does it always need to be there? That's a question you could take. But just let's skip to the answer. Most of the people say A, this case, and they're right.
Mm-hmm.
So the other ones are not true. In that regard, they are partially true because a protection domain can contain a consistency group, but doesn't require one. And the synchronous replication actually works not as a protection domain on the schedule, but it works by connecting data stores together. So it's a different mechanism, right?
Yep.
So all replications
require
next
question,
domain, but you connect them differently. Yeah.
Which of the following statements are true for asynchronous replication? NearSync provide a 1 minute minimum replication. Each cluster must have at least 2 nodes, RF2. Retention policy are only available on the target cluster. Unidirectional replication require remote site setup on both source and target cluster.
So let's see the answers coming in. We got DA, we got A, ACD, AD. So we got a little bit of a mix, more ADs, got a single D as well.
It's a multi-answer.
Multi-answer. So yeah, I didn't state multi-answer, but so if you said D, maybe add one more to it, and then you're already halfway. So the majority thinks AD over here. So what do you think?
It's A and D, and I will explain why not everything. So you can do also replication for a single node cluster. It's not minimum of a 1 node, of a 2 node, and retention policy is set from the source cluster. Let's move to the next one. An async replication protection domain can contain what type of entity? Choose 2. What async replication, not a sync replication, be aware. We have a storage container, virtual machine, storage pool, and volume group.
So what are we trying to sync here? Yeah. We got B&D, lots of B&D. Yeah, it's actually a pretty simple answer if you look for the wrong ones first.
If you know it, so you know it. Yep. Which replication statements are correct? One consistent group can include multi-PDs. at least one PD must be configured. One PD can include multiple consistent group. At least one consistency group must be configured.
So we see.
And it's also multi-answers. Yeah, you can take.
We got some BCs. We got an AC and a C. We got a C and a B, which is B and C. Okay. So I think the majority would settle on B and C. Okay, so what do you think, Ophir? See what the answers are.
It's not fully? Okay. So the answer is B and C. Okay.
Yeah, so
consistent group must be on this because consistency group is a group of VMs and we want to take him, for example, the same schedule time. So we can't split consistency group include based on few multiple PDs. Okay, and this is why not. And once we configure, at least one PD must be configured in the group. Okay. And one PD can include multiple consistency group. Okay, we can decide a group of VM that will be based on the same consistent group, and at least one consistent group must be configured. It's incorrect, okay, because we can do it. Question 6, which is the true for PD activate and migrate option? Migrate is initial from the source site. Activate is initial from the source site. Activated is initiated from the destination site. Migrate is initiated from the destination site. Go over.
yeah, there's only one correct because now you need to know what the difference is between an activate and a migrate, right? Activate is unplanned and migrate is planned. And we have a lot of people saying A and C. So that should be the right answer, right?
Yeah. Okay. So as we say, migrate can be done from the source and not from the destination. And it's a planned and activated, initiated from the destination side. And if it's unplanned, okay, in case our production was failure. Okay, let's go over. Okay, so later on, we created something called Prism Central that's seeing that connection and connect and manage the entire clusters from a single pane of glass, and we don't need to connect to a Prism element and seeing our VMs and the daily operation. We can use it as a central system, and it's installed as a separated VM, okay, from the cluster himself. And it's a VM. It's not mandatory that it will run on a Nutanix cluster. It's a run on a separated cluster and can manage lots of clusters. Based on Prism Central, a lot of features and our new features and more features that are driving in are today based only on the Prism Central. For example, self-service for AHV, that users can create a VM for themselves based on a quota and based of images that we are assigning for them. Calm for automation, that we can build the blueprints and blueprints for automation, and flow from microsegmentation. I'm sorry, my time that I'm stopping. Any chance that you can switch me over? I just
yeah, so you mentioned, I'll pick it up. I'll pick it up, no problem.
I just got called. Sorry, guys, I just got a call, an urgent call from my school kids that they have some issue, and this is, by the way, part of the working from home. Yeah, so
that happens, and we all get used to it. So, hey, thanks, Ophir. No problem. I'll pick it up where we.
I will try to back in a 10. Give me.
Yeah,
okay?
I'll quickly need to find the slide that you were left on. There we go, and then we go here. Share. And now you guys also need to see it. So there we go. And share. Should be all good. Can I get a thumbs up, Oliver, if you see it? Perfect. Okay, here we go. So Prism Central, yeah, like Ovi said, it's a separate instance that actually allows you to monitor and manage multiple clusters at the same time. Also, again, from a single interface. Excuse me. And you can deploy it as either a single virtual machine, but if you want more resiliency, we can actually do a scale out deployment, as we call it. And we can spin up 3 separate virtual machines. It is perfectly fine to run this on the same cluster if you want. So you can actually put Prism Central on a cluster that you're managing it. But obviously, if you want to have more resiliency, placing it on a separate management cluster would then make more sense. Prism Central itself is a VM that has many built-in functionalities. So not only does it do multi-cluster management, it also has the functionality of Calm, Flow, Leap, run books, all that stuff already embedded in it. And you only need to turn it on if you want to use it. But some of these features require additional licensing. So the basic multi-cluster administration is actually built in and you can use that for free. But if you want to use the advanced features, some of the features we call Prism Pro, you need to do additional licensing. But also if you want to use Calm and Flow, you need separate licensing to be able to use those. Now, Prism Central in itself can be scaled out in a large and a small setting. The reason we do this is mainly because of the amount of VMs that you actually want to manage with it. So there's a different setup between the two. So a large single VM instance will take 8 vCPUs, 32 gigs of RAM, and a small one will use 4 vCPUs, etc. So it's small and large, and it has to do with the amount of VMs you're going to use. We're probably not going to nag you for all these specifications, but it's important that you know. Now, Prism Central actually gets its information from Prism Element. So it communicates with the clusters through Prism Element, which means that if your clusters are being accessed through a proxy, then Prism Central actually needs to be have its port whitelisted. So on the proxy, you need to open up port 9440. This is that if there is a proxy between Prism Central and the element cluster. So this is the standard port for Prism Element, but Prism Central actually communicates over this port as well. So you just need to keep this in mind. If I use a proxy with Prism Central, make sure port 9440 is also open. You can whitelist it. That's done in the settings of Prism Element, but you can also do it through the command line. So you can actually set it from command line if you wish. But just keep in mind that you need to open the port. That's the most important to understand. Prism Pro features, or Prism Ops as it is going to be called. There's going to be a little name change of the product and some regrouping of features, but the main features that you see here are already available in the Prism Central VM, but by enabling the license for Prism Ops or Prism Pro, you will get access to, for instance, the operational insights, the customizable dashboards, the self-service portal, the custom reporting, the what-if scenario and sizing, so the actual capacity sizing options that are in there, the tagging of VMs. For Flow, that's the microsegmentation option, Carbon, and that kind of stuff, you will actually need additional licensing. The self-service portal itself has been added since AOS 5.5, and this allows you to more or less create, if you will, sort of quotas. So I can actually enable the self-service portal, and this allows an administrator to set aside a certain amount of CPUs, a certain amount of storage, and a certain cluster. And then once a user that's assigned to that self-service portal signs on, they only see their own little piece of that cluster. We also use it for other stuff. We can actually use the self-service portal as well to create resources within Calm and also Flow. So it is a multifunctional thing, but it's actually the basis for the starting point for the multi-tenancy that is the Prism Central and Prism Pro interface. So a couple of questions. Carbon doesn't need electrolyzers. No, currently it doesn't. No. So that's the answer to that one. So practice test questions. We got a couple on Prism. So what applies to Prism Central? So A, is it created during foundation? B, the setup, is that done through Prism and 1, 2, or 3 virtual machines? C, clusters and Prism Central need to match hypervisor. And D, is it created by the user as a 1 or 3 VM? So which of these statements are true? What applies to Prism Central? So I see some answers coming in. C, D, I see a D, more Ds coming in by people. So let's see, what is it? It's actually, let me skip the clock. It is D. Why are the other ones wrong? A, simply Prism Central is not deployed during foundation. Simply doesn't happen. It does deploy the Prism element instance because that's inside the CVM, but Prism Central needs to be set up after the cluster has been created. Set up through Prism as 1, 2, or 3 VMs. This was a little gotcha because it can actually do 1 and 3. It cannot do 2 VMs. That's why the answer is wrong. And clusters and Prism Central need to match hypervisors. No, you can just mix and match as you see fit. So the only correct answer is D. It can be created by the user as a 1 or 3 VM setup. So the next one, here we go. What additional features are available with Prism Pro? So that's Prism Central with the Prism Pro license applied. Is that centralized upgrades? Is that the VM right sizing? Is that capacity runway? Or is it the VM tagging? So there are multiple answers are right here. And I haven't seen the correct one yet. Oh, there we go. B, D, B and C, A, B, C, D. Well, let's keep you no longer waiting. The correct answer is A, B, and C. Centralized upgrades, VM right sizing, capacity runway, you need a license for this. The other ones you do, or the other one, the VM tagging, you don't need a separate license. It is something that is in Prism Central only because it's not available in Prism Element. There's no way to tag VMs there, but it is A, B, and C. So next one, which features are only available in Prism Central / Pro and not in Prism Element? So is that the PowerShell commandlets? Is that the self-service with Calm? Is that Flow? Or is that the Analyze dashboards? Or is it multiple answers? So I see a lot of B and C, stuff that's only in Prism Central / Pro and our elements. So we seem to be good on D. We have a C and a D, a C, B and D, and a B. A little bit of a mixed bag, but the actual correct answers is B and C, because the PowerShell commandlets, that's something that Tom showed you in the beginning. That's actually something you can download from Prism Elements. And the Analyze dashboard, even though Prism Central has one, Prism Element also has an Analyze dashboard. So it is not just only in Prism Central. It's also in Prism Element. So B and C are the correct answers. Another one, which of the following applies to Prism Central? Registering of a cluster to Prism Central, you do that through Prism Elements. Unregistering clusters, you do that through Prism Central. Or C, unregistering a cluster from Prism Central, you do it through PE. Or the final one, you discover or register clusters through Prism Central. Not something that we dove into, but there's actually different ways to connect and disconnect, different procedures you need to do to connect and disconnect clusters from and to Prism Central. There's several ways. I see a lot of AD, AC, AD, D only, AD, BD. Well, the correct answer in this case is A and C. So if you want to set up a cluster, you want to register a cluster to Prism Central, that's actually, you need to go to Prism Element, and there's actually a button that actually allows you to, after a Prism Central has been deployed, to actually register with that same Prism Central. Unregistering is also done through Prism Element. You cannot do an unregister through Prism Central. You need to go through Prism Element both times to add or remove a cluster through the Prism interface, right? That's really important. Section 12, cluster maintenance and expansion. This is actually the last section that we will cover of today. So let's dive in. And these are important things because they talk about the actual management, stopping and starting of the cluster. So we already talked a little bit about command line options that you can do, but it is really important to know that there is a procedure to start and stop a cluster in the correct way, right? Because if we would just stop the cluster, for instance, we would stop all the command line via or the controller virtual machines. What actually happens is that you would remove the storage path from the VM. So it is very, very important that the first thing you do before you stop a cluster, you power down all the virtual machines or you move them to another cluster or whatever, but you need to make sure the VMs are off. Now you can do that by hand or you can actually go to the Acropolis command line and do a VM off command, and that actually works with a wild card as well. That's a pretty powerful command, so be careful with that stuff. So second, stopping the Nutanix cluster. There's a command for that. You actually execute this from the CVM. Just do cluster stop. The moment you do this, that's the actual moment you will stop the Stargate servers as well, and that would actually remove the storage from the virtual machines. Now, if you would actually lose the Stargate servers on a single controller VM, no problem. Well, we will reroute the IO to another node, but if you stop the cluster, there's no other node to go through, so you better make sure you do it on purpose and not by accident. You can then verify the results. You can do a cluster status that will show you all the servers that are running and if they're not running anymore. And that's pretty much how you do a cluster shutdown. So if that's been done, afterwards, you can actually go to either IPMI, do a graceful shutdown of the host, or give a command from the CVM or from the host itself to shut it down, or press the button on the actual nodes, and that will trigger a nice graceful shutdown as well. So starting a cluster, cluster should be automatically back up after you bring it on from a power down situation. But if you want to manually start it, type in cluster start, and then when that's all done, you can do a cluster status again to see how the cluster does work. So you also actually do not really need to shut down the CVMs, because if you do a graceful host shutdown, the CVM will stop, but the CVMs will automatically start once the cluster rebooted anyway, because they have been set to automatically start in the configuration of the host. So you don't need to manually stop or start the CVMs. Something you can do later. Right? So there's some extra commands you can do. Maintenance mode. Well, it is very obvious probably. You probably recognize maintenance mode from other hypervisors as well. But maintenance mode actually makes sure that it is no longer a schedulable node. So VMs will actually be moved away or will not be started on that host for maintenance reasons, obviously. If you enter maintenance mode, you need the host ID. If you take it out of maintenance mode, you need the host IP. Those are two differences. Shutting down a host, this is actually how you can do it if you really need to do it. But once again, there is no reason to manually do it. But if you want to do it, there is a separate command from a CVM shutdown. Now, why is this? Because this, if you do it like this, will actually do a graceful shutdown or fill over of the actual storage traffic. So we will first fill over the storage traffic, so it won't be as disruptive as an instant failure of the CVM. So if you really must shut down a CVM, please use that command, right? So we will first move the IO, then shut down the VM. Otherwise, if you use a regular shutdown, it will be like yanking the SCSI cable from the main board. That's how the VM will experience it. You will have a short stagnation of the IO, And then the HA script will kick in and reroute it, but you will have a short period of storage unavailability. And if you can actually plan it, then use the CVM shutdown. The VM won't even notice it. It will maybe induce a little bit of network latency, but that's about it. So very important. So AOS upgrades. Important to know, always first read the release notes. You might think, hey, this is a new update. I want to deploy this, but maybe it's not needed. Maybe there's some caveats. So always check the release notes. Are there any other things that I need to be aware of? Is there any impact on services I use, etc.? Always a good practice, read the release notes before you hit that button. Even though it's very simple and you can just do an upgrade now, you need to know what's happening. It's always important to check Prism Central always needs to be bigger or the same or higher and as the same as Prism Element. So that's also the first component you always need to update. So first do Prism Central, then do your nodes of the clusters. Check if you can actually do the upgrade. If you keep a recent track, it's not too much of a problem. But if you have a 4.6 node maybe somewhere, you might not be able to do a direct upgrade and need some steps in between. But on the support portal, you can find the upgrade path. Always, before you do upgrades, I advise you to do a full health check and update NCC if needed. Then do the upgrade of Prism Central, of course, run the AOS upgrade, and then check if the cluster is again okay by doing the cluster status. You can also check the log file if you want. You can find it in the home directory on every node in the data logs directory. And then you can actually find the more thorough log of the actual update. So doing cluster health checks, we already touched how you can trigger them, but you need to know a little bit more than just this, because there's actually a couple of things that we do with the cluster health check. You can actually manually run it by doing NCC and then health_checks and then run_all, that runs all the checks. If you want to do it by command line, it will actually create a log. We can actually also collect the log. It could be that the technical support guys ask you to run NCC and they can do a log collection on it. But you need to know there's actually 4 info types or status types. So pass, fail, warn, and info. Pass, everything's okay. Fail, we have a problem, must be addressed. Warn, needs to be investigated. And info, that's just a metric or something, or some other piece of info that's not trivial or important for action. So you need to know these 4 status types. Software upgrades, where do we actually trigger them? Well, you go to the software menu, you see it in Prism, it's very easy to find, and you can upgrade all these different components. The most important thing to know is that if you need to do a manual upload of the files because you are not internet connected for one reason, you need the binary or the tarball, and you need the JSON file that accompanies it. Those files are always together, and you can download those from the support portal if you cannot do the automatic download. Now you see here a couple of components. It might be that hypervisor, for instance, shows. It also shows on ESX, but be mindful that the hypervisor updates for instance, ESX can be done through Prism, but only the big updates. So the big upgrade bundles, not the individual hotfixes. Firmware, that's something that we're moving also to LCM. That depends on what kind of a host you are actually using. This is still an older screenshot. So checking the status of cluster services. So if you would do an upgrade and afterwards you would do a cluster status, actually you get an overview of all the services that are up on the cluster. So a little pop quiz question for you all right now. So how much nodes are in this particular cluster? So just type in a number in the chat and see if you can see the right amount of nodes that are in this particular cluster that has an OK status. So this goes back to your the knowledge of the services. So we have 6, we have 3, we have 4, we have another 4, another 3. I can give you the correct answer here. It's actually 4, because it's very simple. Actually, the Stargate service runs on every node, and you see it's here 4 times. So that means if the cluster is up, in this case, all Stargates are also here up on all the individual nodes. The reason why you see Prism with more than one port is that it runs with multiple processes. So that's a little bit of a tricky one. Same goes for Zeus. Zeus has multiple instances, but the Stargate service only runs in one process on each and every node. So that's how you can recognize this is a 4-node cluster. Okay, the log files. Where can you find them? Home directory, Nutanix, data logs, or tilde data logs, same path. That's where you find the log files. Now there's a couple of things that you need to understand. The log files actually also have different severities. They have info, warning, error, and fatal. And they always include the component name or the service. So if you would like to see when the Stargate service failed, the log file would start with Stargate, then it would have the CVM name. So that's most of the time that's built up of the serial number of the CVM, and then the node it is on. Then the severity, that would be a fatal, and then the date timestamp. That's how you can actually recognize the log file. So very important to know, first the component, then the CVM, then the severity. There might be a question in the exam on this. So cluster expansion, there's a procedure for this as well. If you're adding nodes to a cluster, there's a couple of scenarios. It could be a new node to an existing block. So you want to upgrade an existing cluster. It's important for this that you first added a file on the new node that's called the factory config JSON file that actually has the serial number and the position, because if you order a node later than the original order, yeah, we don't know which cluster or which serial number or which block position you're going to put it in. So if you would put it in by default, it would probably show up very weird in the GUI of Prism and show up as a separate node in a separate chassis. If you want to change this, you need to change the factory config JSON file. It could also be that you're adding a completely new block with one or more nodes, and it could be that you are actually moving nodes from one cluster to another. Those are actually the scenarios that you could actually run into. Now it's important for all these scenarios, if you want to have nodes automatically discovered, your switch needs to be able to provide IPv6. This is what we use for node discovery. So if that's turned off, you need to do it manually. You cannot do it by node discovery. Also, nodes can only be added to a cluster if they're not part of another cluster. So you would first need to remove them and make sure they become discoverable again. So if I would actually remove a node, the thing is that I'm actually re-replicating all the data to the rest of the cluster, assuming I'm removing the node. After the data has been sort of evacuated, we actually don't evacuate the data, we actually re-replicate it to the other nodes so that it's in the correct RF state again. But then the node becomes discoverable again, and then you can add it to another cluster. Please first reclaim the license of that node before you move it to another cluster. That can be actually done through the partner portal as well. The support portal. That's where you can actually reclaim licenses, and then we can actually add it to another cluster. Please do this beforehand. You can do it afterwards with the use of with the help of the help desk, but if you do it beforehand, please make sure. Right? Always works easier. So, some questions on this. Question on AOS. What applies to AOS and NCC? Can it be upgraded separately, NCC? NCC, is it part of the bundle, the AOS bundle? Is it installed AOS on the Satadom AOS? Or do we need to upgrade AOS first and then NCC? So which are the correct answers? It will be pretty easy to pick out the bad ones. So I see a lot of A and Bs coming in. And let's show you what the correct answers are. So indeed, NCC, it's a separate upgrade. It might very well be that there's no new AOS version, but in the meantime, we have released a new NCC because we added new checks or we fixed some false positives. So yep, can be upgraded separately. So keep that one up to date as much as you can. And NCC is also part of the AOS bundle. Most of the time, if we have AOS released, there is a new NCC bundled. The other two are not correct because AOS is not installed on the Satadom. It's actually inside the CVM, but we actually don't physically install it on the SATA DOM. It's inside the CVM, and the CVM lives on the SATA DOM, so that's correct. And you first need to update. It says first upgrade AOS and then NCC. Now, please NCC, make sure that the cluster is healthy, do all the checks, then you do AOS. And you might even get a new version of NCC at that point as well, but that's the correct order. So what command places a host in maintenance mode in AHV? So is that through either the ACLI or the NCLI, and does that require any other command? So which one is it? It's actually no understanding of the fact, it's just knowing how it works. So which one of these 4 is the correct answer? So I see some A's and I see some D's. So A and D. So the people that did A and D, think, is it the correct command line that I'm actually in? So which one am I actually working on? A or C? That's a command that I also see. Well, let's take a look at the answer. It's actually A. So if I want to move a host in maintenance mode, first thing you need to do is go onto the ACLI. That's the command line that you execute host commands. So that automatically invalidates B, and it also invalidates D. The command is actually host enter maintenance mode, and then the host ID is separate. It's not correct in the C command. That's actually ACLI maintenance underscore mode. No, the command is host.enter maintenance mode. That's just, you need to just remember this. There's no understanding, just remember the command line, right? So what allows a node to be added to a cluster using the Prism expand cluster option? What allows a node to be added to the cluster using the Prism expand cluster option? What needs to be there? Does it need to be discoverable through IPv6? Should the node not be part of a cluster? C, discoverable through IPv6. And D, the node and the cluster need to have the same AOS version. Now think very carefully, because we didn't cover everything. So I see a couple of answers coming in, some BC, CD, B, ABD. So we're a little bit divided still. So let's dive into the answer. Correct answer, B and C. Now, why are A and D wrong? A is very simple. We don't do discovery over IPv6. We only do a direct add. So if it already has an IP address from a previous installation, you can use that to add it to the cluster, but it won't be discovered. B is a correct answer. Told you it cannot be part of a cluster. It needs to be removed. C, node should be discoverable through IPv6. So that's the correct statement. And D, the node and the cluster do not have to be the same version. The thing is though, you can actually start the adding process, but before it is really added to the cluster and really usable, actually the addition process will upgrade the node to the cluster version. So it does not have to be the same at start, but it will end up being the same because it will be automatically upgraded. So that's a little bit of a tricky question there. So 12.4, getting near the end, guys. For upgrading the hypervisor, what files are found on the support portal? And this is one that I didn't particularly mention as a hypervisor, but what files do we need to upgrade the actual hypervisor? So do we need a binary file to upgrade AHV? Do we need a binary file to upgrade ESX? Or do we use a JSON file to upgrade Hyper-V? Or do we need a JSON file to upgrade AHV? So most of you are thinking A and D, and it's actually a tricky question because of the C one. It says, yeah, JSON file to upgrade Hyper-V. Well, you need that too, people. So sorry, the thing is you need a JSON file for all the hypervisors, but you also need the ISO from Microsoft. So in this case, the binary file from ESX doesn't exist because you need the VMware ISO. But Frederick, who cares about Hyper-V? Well, we still do, Frederick, but you're right. It is not a much used hypervisor, but you still need the JSON file. So you need a JSON file and a binary file for AHV, and you need a JSON file and an ISO for the other ones. So that's the tricky question here. So what's in the, let me elaborate, what's in the JSON file. Those are actually the ISO CRC codes that we have tested and validated. So that's why you need the file, so we can validate that the ISO you use is the one we tested and not some custom one that might cause compatibility issues. That's why we also have the JSON file in place. Now don't go edit the JSON file and add your own CRs in, please. That might cause a support issue. Just use this, find the right ISO. So a tip is if you need a correct ISO, just copy the CR or MD5 code out of the JSON file, dump it in Google, and you probably get directed right to the correct file. For ESX, that always worked wonders for me to find the correct ISO. 12.5, so to physically move a node, what do you need to do, in which order? So shut down the CVM, power off the node, put the host in maintenance mode, and shut down the guest VMs or move them to another node. And this is physically move the node. I'm not talking about putting it in another cluster, but if I want to move the node into another chassis, what do I need to do? Which order? Is that A, B, C, D, or any other order? So I see DCAB, DBCA. So think about what happens if I do a certain thing, right? So what happens if I shut down the CVM? What happens if I power off the node, right? So DCAB, I see somebody say A and C. Well, then you're missing a couple of steps. But DCAB seems to be the good one. You need to have all the steps, people. You cannot lose one in this case. So the correct answer is first, shut down the guest VMs or move them to another node. That's really simple, right? We need to protect our data. The second one is that I need to put that actual host in maintenance mode to make sure that those VMs don't move back. Then the third one would be to, at that point, and this is when you can actually combine. You would do the graceful shutdown of that CVM, but you can actually combine it and just power off the node because it will automatically shut down that CVM, right? So do this as an automated one and just shut down the node. But this is the steps that are actually happening. Doesn't mean you need to perform number 3, but it actually happens before the node shuts down. So D, C, A, and B is the correct answer. If you have put B anywhere at the first ones, you're going to have lots of angry users. 12.6, an administrator must install a license after creating a cluster for, put in a word, licensing, or put in a product, and why license before destroying a cluster. So what do you need to do? If you install a license, for which product do you need to add it after creating the cluster, and for which ones, what do you need to do before you destroy a cluster? So you need 2 answers. What needs to be put on X and what needs to be put on Y? So which kinds of licensing? Okie-do. Here we go. Those are the correct 2 licenses that you need to add. 12.7. Where are most AOS services and NCC logs found? So this is just remembering the directory, the home directory where we put the stuff in. So there's no teaching you, there's no explaining, there's just knowing. And the only correct answer, of course, is A. No, I'm kidding, it's C. Home, Nutanix, data, logs. That's where we put the data. Do you need to do something with the logs? No, most of the time, support engineers will ask for it. You're free to look around, of course, but there's a lot of data in there that's not really used for daily operations. For generic day-to-day tasks, the system admin doesn't really need the log files. 12.8, what command is used to run the Nutanix cluster checks from the CVM CLI? So what do I need to run if I want to run all the checks there are? Which of the commands do I need to run? And this is again just remembering. what is the command called? So we got a lot of B's. So for the sake of time, I'm going to all say you're right. NCC, then the health checks, then run all. If you want to do specific checks, you can actually remove the run all and put a specific category in place and just run those. But as health checks are pretty fast nowadays, yeah, normally when I use it, I just run all because yeah, it doesn't really matter anymore too much. So we've come to the end. We're a little bit over, so thanks for bearing with us. I hope this was of use to you. Make sure you grab the last keyword on the page here. My thanks to my fellow presenters. I hope the panelists got your questions all covered and the presenters clarified everything for you. Had my honor of stepping in quickly myself as well. If there's any questions about the exam or more information, or you would like to do something else, do more training, just send me an email, martijn@nutanix.com. I'll make sure that it gets relayed to the proper places. Make sure to claim your rewards, immediatepartner@xtribe.nutanix.com. And the only thing I can now say is, guys, best of luck with the exam. I hope you can claim your points. Make sure you go on social media, show us everything. And last thing for me to say is thanks very much. Have a good day, good luck, and bye-bye.